Good morning, everybody. I think let's go ahead and get started, at least with the introductory stuff. My name is Josh Winchell. I'm an assistant research scientist here at High Performance Research Computing at Texas A&M University. And today we're going to be talking about Python. This is the second class in this Python series. These classes are meant to feed into one another, but also be more or less standalone. So if you just joined us today, that's fine. Last time we did Python for new programmers, that is introduction to both Python and programming for people who hadn't done any of that before. Today is Python for programmers new to Python. So this is generally assuming y'all have done programming before, perhaps just in that first class, or else you're a programmer in a different language and you've never used Python and you just need an introduction to the language. Again, these classes are meant to be sort of standalone. So what we're going to do today is going to have a little bit of overlap with what we had in the first class, in case you were there. So if you were with us in the first class, we'll have time for a review today. And if you're just joining us today, some of that stuff that's reviewed for other people will just be an introduction to the Python syntax for you. And then after this class, you should be set up for our final two classes later in the semester, Python for data scientists and Python for HPC. Things that we'll be covering today, though, again, some review of programming basics and or the Python syntax. We'll go over control structures and then start on Python data structures, get a little bit more complicated. All stuff that will be very useful to know for those later classes later in the semester. So most of today is going to be spent in two Jupyter notebooks, which I'll introduce in a little bit. First of all, though, I have a few quick words about Python kind of broadly, where it sits in the programming world. We'll have some time to make sure everybody can get onto the system and has access to the files and that they work. And then, as I said, the rest of the class will be two main interactive Python files for basics and control structures and data structures. If you have any questions along the way, of course, please let us know. You can send us messages in chat. We have several HPRC people in there to help you. And I'll be watching chat as well to answer whenever I can. So let's start off and talk kind of broadly about Python. What is Python like? What kind of programming language is it? Python's a pretty high level language, which means it's very friendly to you, the human programmer. Like there's a lot of levels between it and the machine itself, so you don't have to speak good machine words. The joke in Python is that you can write pseudocode and it works, which is something of an exaggeration, but it gives you the gist of it. The syntax in Python is pretty human readable. The goal is to make it so that you can think about, the algorithms you're writing instead of worrying about managing little bits of machine memory or whatever. So the gist of Python is that ideally you can code fairly quickly, fairly easily. The trade-off being, though, that it may not be quite as performant as some other languages. Since you're not going to be managing individual bits of memory or whatever, maybe your Python code won't be quite as efficient or as fast as if you'd written the same thing in C++ or something. That's what this slide is. So is Python right for you? Well, it depends. If you don't have to squeeze every bit of performance out of your computer, Python can be a very good option. It's relatively easy, relatively quick. It's very extendable, very portable, all good stuff. It's if you become like a power user and really need to get everything running in absolute lockstep, perfectly using memory super efficiently, maybe there's a better option. On the slide here, we have under the con source code style is mandatory. We'll talk more about that later. I don't think that's that much of a con. What that's referring to, though, is some things that may be stylistic in other languages are required in Python. We'll get to that in a little bit. If you want to know more beyond the things that we cover today, you should be aware of these resources here. We have other courses that you can check on our training page. This link here is the training webpage itself. Let me, in fact, show you how to get here because that has useful things. In your browser, if you want to go to hprc.tamu.edu, or else you can probably just, search engine HPRC TAMU or whatever. You should end up here on our homepage, and under the training tab, go to courses. And then this is where All of our courses are listed, so look through this sometime if you're interested in learning other things. But in particular for today, you can find today's class down here, view details. The link to this page is also in some of the reminder emails that we sent out. On this page, which is where you're registered in the first place, you can find, first of all, a PDF of the slides I'm using today, which isn't a whole lot, but if you want to check back on these later, you can find that on the course page. And it's also got the 2 Jupyter Notebook files, or IPython files, that we're going to be using today. So if you have trouble getting onto ACES, for instance, you can just download these and run them somewhere else if you need to. If you have your Access ID set up with us, though, we should all be able to run on ACES in the same environment today. I got some messages, yeah. If you're having login errors, send those to the full chat so some of the other HPRC folks can help. There's other people who can get to accounting stuff faster than me because I'm showing slides and things. We're going to have dedicated time for that, though, in just a minute. Let me finish up here real quick. If you want to know more about Python and using Python on HPRC, see also our knowledge base at this link here. You can also find the knowledge base from any of our HPRC pages with the W up here. And then you can find Python under the software tab down here. We have a bunch of videos on our YouTube channel, including recordings of these Python classes. This class is being recorded. It'll get posted here eventually. There is some processing time, but you can find our older Python content on our YouTube channel at this link, or again, from one of our HPRC pages. We have a YouTube button up here. The channel looks like this. And also, if you got an Access ID, you have access to a bunch of other Access support links, including like links to other documentation and whatnot. Okay, so let's go ahead and make sure that everybody can get on. Here's what I need you all to do. I'll give you all time for this. On one of our HPRC pages, so again, you can start at hprc.tamu.edu, or if you have the course web page up, you can get it from there. I'll just go ahead and post this in chat in case you all need it. Just posted the course web page in chat. What we're going to do is find this portal dropdown and go to the ACES portal. Make sure it's the ACES portal in particular. That's the one that has the dedicated app that we're going to use today. When you click on this, it should send you to an Access login page, or possibly an institutional login page. It depends where you've logged in already. Once you've gone through all the logins, it should drop you off on a page that looks like this. This is our ACES Open On Demand portal. The Access login will look something like this. You'll choose your institutional identity provider, or possibly just Access itself if you just use an Access password. So log in with Access, log into your institution. You should end up on the portal page. I'm going to give you all time to do that. Let me go ahead and do it myself, actually, just as a demonstration. So here I'm on some HPRC page. They should all have this header. Go to the portal dropdown, ACES portal. Make sure it's ACES portal Access. Go to ACES in particular. I have not logged into Access yet, so it takes me to this page. I select Texas A&M University as my identity provider. That may not be the same for you. It depends how you set up your own Access ID. I work for Texas A&M. I set up my Access ID with Texas A&M, so that's going to be my identity provider. I log on. It'll send me to the Texas A&M login screen. So y'all may not have this if you're from somewhere else. I log into Texas A&M. That passes it off to Access. Access gives the OK, and it drops me off here on the ACES portal. It looks like this. So I'm going to give you all a couple minutes. Get to this screen. If you have any trouble getting to this screen, let us know. Once you're on this screen, I request you give us this green check mark in Zoom. So that's under the React button, green check mark. I request this one in particular because it's persistent, so it lets us keep track of who was able to get here. So I'll give you all a couple minutes for this. Give me the green check mark once you're on the portal, and if you're having trouble, let us know in chat, and we'll try to get you logged on. I think most people had Access IDs already. Most of y'all gave it to us when you registered. In case you need it, though, I want to point out we have this Getting Started with Access page. In case you do still need to set up an ID, post that in chat, just in case you need that for reference later. In case anyone's having the same issue that Farnish is, trouble with institutional ID, when you log into Access, how you get in will depend on how you set up your Access ID. So I got in with my institutional credentials, my Texas A&M credentials. when you're creating an access ID, you also have an option to create like just an access only password. So if you do have trouble with your institution, if you set it up this way, you can try getting in with this access CI exceed login in case you remember your password for that. That's an alternate option in case your institutional ID is not working. So I just want to get a sense for where everyone's at. 14 people got on okay. A few people in chat having trouble. If anyone else is not able to reach this page, can you select the red X? That way we can send someone to you if need be. If you are still having trouble and are trying to get in, again, please send us a message in chat and we'll try to help out where we can. And again, in case you're not able to get on today, you can download today's files from the course webpage and run them elsewhere if you have to. I think for today, you probably don't need any special environment for these particular files. For the later classes in the Python course, running it elsewhere may require some additional setup. I think these ones today are fairly simple though. There may be some version differences today, but that shouldn't be too insurmountable. Okay, let's go ahead and get going then. So once you're on the portal, you're going to go to this Interactive Apps tab at the top and look for Jupyter Notebook for Python Training. So I'll do that myself real quick. Okay, so here I am in the portal. I'm going to go to Interactive Apps. And there's several options here that have the word Jupyter in them. You specifically want Jupyter Notebook for Python Training. This one is set up specifically for us today. Like it's got reserved nodes back there, so we don't have to compete for resources. When you click on it, it should give you a really tiny form looking like this. You shouldn't have to mess with it. One core is fine. I'm not even sure if it lets you change it. No, it doesn't. So just launch it as is. It'll take you to this page here. I've currently got a Jupyter Notebook for Python Training box. It's light blue. It says queued. That means my job has been submitted. It's looking for space. Okay, it's changed slightly. It says it's starting. It has now found its resources, and the job itself is just getting set up. Programming is starting to run. Just wait for this for a moment. I think my slide shows the same sort of thing. Yeah, we're going to wait for the box to turn green, and we'll have a Connect to Jupyter button like this. Okay, mine is running. It's ready to go. I have a Connect to Jupyter button. Click that, and you should get this sort of file browser looking thing. So what happened in the background here with this particular app we launched, it copied all the relevant files for you into your own personal space on the cluster. So I think we should all have these same three files here, one folder and two IPYNB files. And we're going to start with this basics review. And I think that's all my slides for today. Yeah. So in case I forget it later, check back on the slides later. We have a short course survey. We'd appreciate you filling that out. You can come back to that later, though. For now, you just want to open this file here, basics review. And it will look something like this. I'll give you all a minute to get here. Again, if you have trouble along the way, send us a chat message. In case, so just in case you lose this box, this page here is the My Interactive Sessions tab in the portal. So if you happen to click somewhere else after you submitted your job, go to My Interactive Sessions. There it is. You can reconnect. In case your job like desyncs or something, you can always just come back here and hit Connect to Jupyter again. It'll just open a new tab. It'll have all of the work that was auto-saved. So let us know if you have trouble. Otherwise, I'm going to go ahead and get started. So let's talk about what we're looking at first. You've opened a file with extension .ipynb, that stands for IPython Notebook or Interactive Python Notebook, and we are running in particular in the Jupyter Notebook editor. There exist other ways to run this type of file than Jupyter, and there exist other ways to run Python than IPython notebooks, but this happens to be a pretty good way to learn Python. And I should be clear as well, like it's not just learning Python. When I was doing my PhD work, I was in Jupyter Notebooks like every day. It's really good for making like good, presentable, interactive Python, which makes it good for teaching, but also good for other things. Really good for sharing with other people. It's good to document. Got a lot of tools supporting it, stuff like that. I do want to point out that we're using this particular setup though, because again, you could run Python somewhere else. You could run this notebook somewhere else and the interface would be a little bit different. I think most of the stuff I talk about today is going to be like interface agnostic. Most of it's just Python that will work anywhere. There are a couple things that will only look this way in Jupyter though. I'll point those out when we get to them. So you have this front-facing interface here, very nice and human-friendly. It's connected to the cluster in the background somewhere. In case that connection gets like desynced or otherwise messed up, you can try restarting your kernel, which is under this menu up here, kernel, restart kernel. If everything stops working suddenly, try doing this. It'll usually clear it out. Doing that will not get rid of your code. It will make it forget any like definitions you've executed, but so like, for example, if you accidentally overwrite an important keyword in Python or something, which can happen, then you'd want to restart your kernel to get that keyword back. Okay, let's talk about cells. Cells are the basic like organizational unit in an IPython notebook. So even if you run this in another editor, you'd still have cells. There's two main types of cells: markdown cells and code cells. So click on this text once, and you should see this bar appear on the left here, or click somewhere else. You'll see it hop around to indicate which cell you selected. This particular cell here, with the big cell header, this is a markdown cell. Click once on it to highlight it on the left, click twice on it, and now you see the underlying markdown here. We're not going to be doing a lot of markdown today. I just want to show you this happens in case you accidentally like expose the markdown and want to get back to the normal text. To render this, you can hit the play button up here in the menu bar. Then it gets back to this nice readable text. Or you can also, well, there's run options here under the menu, but those also have corresponding keyboard shortcuts. And I use those keyboard shortcuts a lot. So say I'm back in the markdown here. You can do Control-Enter, make sure the cell is highlighted. Control-Enter will run the cell and leave that cell highlighted. Oftentimes what I do though is Shift-Enter, which will run the cell, it'll run the cell and highlight the cell below it. So if you have like a bunch of code cells in a row you want to run, you can just like spam Shift-Enter to run through them all. Now immediately below that markdown cell we just played with, we have two code cells. You can identify code cells very quickly because they have these little brackets here on the left. Once you run these cells, and you'll run them the same way that you did the markdown cell, once you run the code cells, you'll get a number in here showing you what, showing you what order you executed the code in. So select this first code cell. It says print, and then it has all this text in here. I'll hit Shift-Enter in my case. You can do Control-Enter, whatever you want. Shift-Enter, and it ran the code cell. And it printed out this code that I gave to this print construct. We'll talk more about that in a little bit. And you see once I executed it, I got a 1 inside the brackets here. That shows it's the first code cell I executed. That is, it's the first code cell that I sent off to the Python interpreter in the background. So if I run this next cell, Shift-Enter, it's got a 2 in it. That's the second thing I sent off. If you want, you can re-execute these cells. So if I just hit Control-Enter a bunch, you see that number is getting incremented. And I can run this previous cell like this as well. You can run the cells in any order you want. You're just choosing which like block of Python to send off to the interpreter, and you can do that in any order you want. Interpreter doesn't care. Now, next thing to note is that when you highlight a cell, see you have these buttons on the right that pop up. Those will let you copy cells, move cells, add new cells, and delete cells. Please add cells like anytime you want. It's free, it's easy, and it's a good way to try like variations of code. like say you like whatever's in this box and you want to try a variation of it, add a new cell. You'll make one below. I can like copy the code in. I guess I could have just done the duplicate option as well, whatever. But then, edit whatever's in here. So adding cells is a good way to try a variation of some code without losing the original code. So I'm going to give y'all a minute or two just to warm up. Scroll down to this exercise Hello World. Your goal here, your assignment, create a new code cell below this markdown cell and write a Hello World program. You're basically just going to be copying this sort of print syntax up here. Just write a code cell that will print out Hello World or whatever you want. I'll give y'all a minute for this. Have at it. Okay. I wasn't tracking how long, but hopefully this is fairly straightforward. What I would do, I like my keyboard shortcuts. There's a shortcut for adding a new cell. You can actually see it if you hover over these buttons here. You can create, oh, now it's not hovering. It's hovering for me earlier. There we go. So you can insert a cell above with A or below with B. So usually what I do is I select the cell. Usually I click someone to the left here because it works different. Maybe I'm getting into the weeds. The Jupyter Notebooks have both a command mode and an edit mode. If you double click the cell, right, this is editing. And if you hit that A key, you get the letter A because you're editing. Make sure you're in command mode, like select to the left here to do that. Then you can do your commands hotkeys. So here I'm going to hit B for below to create a new cell. And I will make my own hello world. Print hello world. Copying the same syntax as up here. Then run the cell. And it works, typo and all. And of course, y'all don't have to use a keyboard shortcuts, but that's just what I'm used to, having done Jupyter forever. You can just use these buttons here if you want. Okay, any problems on this so far? We will introduce a bunch more ways for things to go wrong, so hopefully at least the starting point is okay for everybody. Let's go ahead and move on then to elements of code. So again, if y'all were with us for our previous class, a lot of this is going to be review, shortened a little bit, but I want to go over the stuff again, both for review for you, but also for the new people joining us who just need to see the Python syntax. We'll see what it looks like compared to other languages. So first of all, how do you comment? Comments are important. Comments start with the pound sign. Whatever you put in there, Python ignores them. So if I execute the cell, I just get the results of these print statements down here, no matter what was up in here, because it's all comments, it's all ignored. One keyboard shortcut that I use a lot, which might be helpful for you as well, you can toggle whether or not a line is commented by highlighting part of it and hitting Control/. So if I select just this one line here, Control/, turns it into a comment. Press it again, toggles it back off. So back and forth. You can also just highlight some lines that you want. It doesn't even have to be the whole line. And that same shortcut will toggle commenting on all of them. Be aware, of course, it doesn't know if it's actual Python code. So you can also toggle comment on the actual comments itself, which Python won't like if you try to run it, but be aware of that. So that's comments. Let's now talk about actual Python things. Let's talk about data types and operators in Python. So let's start off with strings. Strings we've seen already. They're colored in dark red. It's text, stuff like this. So like all the stuff we've been giving to print statements, it's all been colored in red. Those are strings. If you're coming from other languages, you may have seen like a separate character type. Python does not have that. So like, if I recall correctly, C++ has the character type for like a single character, right? In Python, a single character is just a one character string. It's just a string, same as usual. On a related note, likewise, the single and double quotes have basically the same function. Within a single string, whatever you start it with has to end it, but otherwise the single and double quotes are basically interchangeable. So see, for example, this code cell down here with the two print statements. This is a string in single quotes, and this is also string in double quotes. These are both strings exactly the same way. Print them both out, they're strings is strings is strings. I can change the single quotes to double quotes, and nothing changes. Double to single, same deal. Now this can be handy on the one hand because it means it makes it kind of easy to use one type of quote and the other, right? So if I change this first string here, I can say I apostrophe, I'm a string. Since it's in double quotes, that single quote comes through just fine. Now this is kind of a simplified example. It may be that you need a string that has both single and double quotes within it. Well, then what do you do? In case that comes up, let's see. So this says I'm a string. This is a problem, right? Because I've got both double quotes and single quotes in here. If something like this arises, you can escape them with the backslash. So now the whole string is in double quotes, but I was able to get double quotes within the string with this backslash character in front of the ones that are part of the string. That makes sense? Any questions on that? You should also be aware, you can also do triple quotes. Triple quotes are a little, excuse me. Triple quotes are a little bit different because they will let you do like multi-line stuff. Like you see this text here is all still red. You may also use triple quotes for like doc strings if you're writing a custom function or something. We're not going to be doing custom functions today, but in case you need to know for the future. Okay. One side note here, which is not specifically about strings, but it's about how Python and this interface works. I've so far been putting everything inside of a print statement. You can have stuff be printed out in your like output cell without the print statement, but Python will by default just parrot back the very last thing you send it. So down here, I have the same strings that I started with up here, but now they're just like naked outside of a print statement. If I execute this cell, I only get the last one back. So the first, this is a string, doesn't show up, only the last one. And it's also added this other formatting with these single quotes here that I didn't give it in the first place. For this reason, I recommend being in a habit of putting things inside print statements if you specifically want them printed out. If you're doing like a really quick check of something, like I'm not saying it's bad to just have, you know, an expression there to have the output. The problem is that if you're debugging later, if you're not doing print statements, it's easy to lose track of something. Like this is a problem I sometimes hit myself with. Like I'm checking something. So this is a dummy case, but hey, Python, does 1 + 1 = 2? Yes, cool. I come back to the same code later. Hey, does 2 + 2 equal 4? It equals 4, but where'd my 1 + 1 go? What happened? It's not showing because I didn't print it. So again, my takeaway here is get in the habit of printing things. It's a way to make sure that the formatting is right and to make sure that it always does get printed out. Because once you start doing more complicated code than this dummy example here, it's easy to lose track of what is getting printed out and you'll lose something that you're looking for. Okay. Final note on strings for now. There's a bunch of ways to operate on strings, but for now we're just going to see this one here. Use the plus sign for concatenation. In this print statement here, I've got two strings. This one here, highlighted in red, it was best of times, and then the second one, space, it was the worst times, and just connect them with the plus. Run the cell, and you get this single string printed out. Now, when you're concatenating like this, though, watch your spaces, because like if you first write out something like this, you may do this. It was the best of times, comma, it was the worst of times with no space. But the space itself is a character. So if you don't add it into the strings you're concatenating, you may find, stuff glued together with bad grammar like this. Okay. Any questions on strings so far? Again, we'll do more with them later, of course, but this is just the basic syntax. Does this all make sense so far? Sidebar in chat. Zoom client catching up. Yeah, if in case there's latency or something and you miss something that I do, let me know and I'll repeat something. Okay, let's move on to numbers. So in base Python, there's really only two kinds of numbers: ints for integers and floats. Other languages will have a bunch of detailed types of varying specified sizes. Python can also do that, but we're not going to see that in this class. That'll come with like some of the extensions that you use in data science. So if you want to know more about data science, see our Python for Data Science class, which is I think scheduled for November sometime. Keep an eye out for announcements from us for when that's set. For today, though, dialing back, we've only got two types of numbers: the ints and the floats. When you write out an int or a float literal, Jupyter will color it in dark green, as we see here, and as we saw in my dumb example up here. Just go ahead and run the cell. Prints out about what you'd expect. We have the int 5, negative 5.5 float, and you can also do scientific notation with the E notation here. So 5e5 is 5 times 10 to the 5, right? That gives us 500,000 here. Now, operating with numbers, you can do all the basic math you'd expect. If you want to do fancier functions like your trig or use special things like special numbers like pi or e, there's extensions for that. Base Python will not do that. Again, check out our next class if you want to do those. But most of the basic math will work the way you expect. So execute this cell if you want. Shows you addition with the plus sign, pardon me, multiplication with the asterisk, division with a single / You can do integer division with a double slash, and the corresponding remainder or modulus to your integer division with the percent sign. Go ahead and run this. And main thing to note, if you're coming from another language, in Python, exponentiation is 2 asterisks. Your instinct may be to use the caret operator. This is dangerous because the caret operator is in fact a valid Python operator. It's just the thing it does is not exponentiation. 5 to the 3rd power is not 6. This is what makes it dangerous. Like, you're going to accidentally put the caret in some calculation of yours, and it'll run it through and not give you an error, but you'll realize the answer's weird. Well, that's because it's doing something else without complaining about it. In case you're interested, so sidebar, if the things I'm about to say don't make sense to you, don't worry about it. This is just for the people who are familiar with this kind of operation already. In case you're curious, the caret operator is the bitwise exclusive OR operator. So like what happened here, 5 and 3 is 6. Binary for 5 is 101, right? And binary for 3 is 011. So the exclusive OR on this, we have 1 and 0, so that passes, that's a 1. We have 0 and 1, that passes, that's a 1, and then 1, 1, that doesn't pass because it's exclusive OR. And the result of this is binary for 6, right? 4 plus 2. So that's what this operator is doing. Again, if you didn't understand any of that, don't worry about it. We're not going to use that today. I don't think we're going to use it in any of our Python classes here, but in case you see it later, and you know what bitwise exclusive OR means, that's what that operator is doing. Okay. Any other questions on the math on these things up here? Okay. Seeing no questions, there's a question. What is the integer division one? So 9 divided by 4 is not 9 divided by 4 is not actually an integer result, right? But sometimes you specifically need an integer, like you just need to know how many whole times something goes into something else. The integer division, the double slash, that will just give you an integer result. So like, in this case, you see here, compare these two lines. 9 divided by 4 with 1 slash gives you the float, 2.25. 9 integer divided 4 just gives you 2. And then you would get the remainder of it with the percent sign. Let's see, does it? Okay, yeah. Maybe I just explained literally what it did. Did that help? Did that answer? Okay. Oftentimes you're going to check if like something is divisible by something else. That's where stuff like the modulus and the integer divide will come in handy. Or sometimes maybe like a function will only work on integers. So you may need to like force an integer result, do something like this. I don't want to generalize too much because it shows up in any random number of places in which it may or may not be appropriate, but this exists. Be aware of it. You'll find use for it later. Okay, so next data type is Booleans. Jupyter highlights them as greens. Booleans are your trues and your falses, and they can be operated on with your logical operators like and, or, and not. So in this code cell down here, printing true and false, that should be false, and printing not false, that should be true. Cool, that works. These will, of course, be very useful once we start doing like if statements and conditionals later on. Now that I've shown you Booleans, this also opens up some other operators for strings and numbers. Some fun operators that we'll be using a lot later. So going back to strings now, let's look at the in operator. We'll be using in a lot for loops later on, but for now, the in operator is a way to check for substrings inside some other strings. So here, check for cheese in cheeseburger and check for oxygen in water. Well, of course, Python's not going to do chemistry for you, so that second one is false because it didn't find the characters for oxygen in water. It did, however, find cheese in cheeseburger, so that one returns true. Returning to math, meanwhile, you've probably seen comparison operators before, greater than, less than, equal to, stuff like that. So 1 plus 1 greater than 0, that better be true. 10 greater than or equal to, multiplying two larger numbers, probably false. And 100 equals, note it's double equals, 100 double equals 10 squared, that's true. And so we get those Boolean results out. Again, make note, double equals is your conditional equality operator. We're about to do something else with a single equals in a couple cells. So having shown you all that, I'm going to turn you loose for a minute. Under this exercise here in the cell, write a statement, an executable Python statement that incorporates all of our data types. Do some fun operations on them and make sure it executes. Take a minute or two for that. I'll check back in a little bit. So here's what I did arbitrarily. It's two logical expressions, checking for car and carburetor. I don't know why I thought of that. Carburetor is just a fun word. And checking that 5 minus 5 is greater than or equal to 100, which is not. So in terms of strings, this one is true. And comparing numbers, this one is false. So true or false gives me true. Did anyone else come up with something they want to share or find any errors that they want to ask about? For fun, I can add a not in here. Okay. Seeing no commentary, I think, I'll just copy this in. So Gaia sent this in chat. Okay. Oh wait, these are probably separate lines. That would make more sense. Oops. So it looks like what's happening with these? Oh, sorry, is that another new line? Okay. Guy, can you explain what you were trying to do here? Because so like I see the end of one string here. Oh, okay. So these two parents match. Maybe what you meant was to print multiple things.
Yeah.
So, okay. So you can pass multiple arguments to the print statement, and you can do that by putting in commas. So here's one thing to print. Let's put a comma in there. These parents here, that might be okay. For now, I'm going to just put another comma here. If I execute this, okay, there we go. So what this did, it printed this first argument, hello world. This is the second argument here. The parents, I don't think, do anything in this case. You can just get rid of them and it prints the same thing. It's another string. 1 plus 2 equals. And then you're printing out this, it's going to be a Boolean value here. Cheese is in cheeseburger, so that gets true. So yeah, here's the first argument. Here's the second argument. And then the third argument. These first two you could combine with the concatenation operator because they're both strings. Maybe you put in the space if you want. This last one, though, returns a Boolean and not a string, though. So I don't think the concatenation would work there. Oh, interesting. I don't actually know how to interpret that. So let me take this opportunity to promote the use of parens. Because sometimes, like, especially these logical operators, they may group things in ways you're not expecting. So like, kind of what I was expecting here was this, I think. So concatenate these two strings and then this Boolean result, which doesn't work in this case because you cannot concatenate a string and a non-string. So okay, I just kind of ripped on this. Do you have any questions about what I did here?
No. So that means we cannot print multiple things together like that?
Say again, I couldn't quite hear you.
I said that means we cannot print these multiple things together, like using the concatenation, this thing like that.
You cut off at the end there again, but you can print multiple things together, either either by just passing them as multiple arguments. Like maybe this is what you meant. You can print different data types like this. The reason this worked and the previous one didn't is because
then
you cannot.
Then why is showing 1 plus 2 equals true, not showing the 3?
You're asking why it didn't do the math for the second one?
Yes.
Okay. What you probably want there is just another argument doing the actual calculation itself, because this is just a string. Or sorry, I changed it, didn't I? What did you have before? Okay, yeah. So originally you still just had this as a string. Python will not do the math just for you on a string. It's just printing the string. You would do the math separately. So something like this.
Oh, okay.
Because like Python doesn't understand within your strings. It's anything. It's not going to recognize if you have math in there. So to actually do the math and have like a label like you did, you'd have a string label and then the math separate. Does that make sense?
Okay. Thank you.
Okay. I saw another comment in chat. Could you explain why the code I used in the mix and match returned true or false? In undergrad, I took a discrete math class in which we did like Boolean logic and truth tables, and I want to show you all those, but this isn't a great way to do it. To explain it as best I can. So let me actually simplify again. So this is what I had originally, arbitrarily. So grouping by parentheses, this or statement has two sort of arguments to it, right? It's got this thing on the left and this thing on the right. Compare this thing, or evaluate this thing on the left first. Is this substring car in the larger string carburetor? Yes, it is. It's right here. So this statement by itself is true. So what we have is true or something else. And frankly, at this point, you're done. True or anything else is always true. That's just the rules of Booleans. For fun though, what I did over here on the right was 5 minus 5 is 0. Is that greater than or equal to 100? That is, of course, false. So this whole thing is false, meaning the entire statement is true or false, which evaluates the true. So Chelsea, this is kind of just like the rules of Boolean logic. Does it make sense what I said? Okay, cool. And then the one complication I added at the very end there for fun, I put a not in front of it. The not just turns true into false or false into true. In this case, the full statement was true. So if I execute it with a not around it, it turns into false. Okay. Let's do one more thing, and then we're going to take a break. I want to talk about errors really briefly, because we start running into them already. I want to talk about how to read them. If you execute this cell as it is now, I wrote this cell broken, you get an error. You get this red box. That's a Jupyter thing. If you run it somewhere else, you won't necessarily have a red box. But you have something highlighting something in your code, and then syntax error, unterminated string literal. So what do you do when this happens? Usually what I do is whenever I get an error, I just jump straight to the bottom. When you have more complicated code, you could have a lot of stuff higher up. Usually the very bottom line will tell you like specifically what kind of thing went wrong. In this case, we got a syntax error, meaning we probably failed to write readable Python code for some reason. It tells us in this case, though, we have an unterminated string literal. Okay, so we started a string, but didn't end it properly somehow. Something broke it. In this case, it was fairly simple. It's that I mixed up my quotes. I have a double quote on the left, And since I started it with a double quote, it's looking for a double quote to end it, but I never gave it one. I have the single quote instead, which it thinks is part of the string. So what I can do to fix it is, excuse me, is turn my single quote at the end into a double quote, and you'll note the parent at the end is back to being colored black instead of red. So now it's recognized that I've actually ended the string. I could have alternatively switched my double quote to a single quote, and that works. As another example, down here, I have 1 plus, that is like the integer 1 plus the string 2. If I run this, again, big red box, I'm just going to jump right to the end. Tells me I have a type error. Unsupported operand types for plus. So I have used the plus, and I gave it something it doesn't know what to do with. In this case, it tells me it found an int and a string, which is in fact what I did. And this is the problem. The plus does addition and it does concatenation, and it doesn't know what to do here because I mixed up my data types. If I wanted addition, I would have given it 2 integers, or possibly have a float in there. It can add floats and integers. Or if I wanted concatenation, I would have specifically given it 2 strings. So takeaway here again from me is when you get an error, don't panic, jump to the bottom. That'll usually tell you what kind of thing went wrong. And then once you've seen the bottom, the stuff in the middle is trying to show you where it thinks the problem happened. In these cases here, we've only got a single line of code, so of course it pointed there. But anyway, that's my approach. Read the bottom thing, then go back to the middle if you don't already know what the problem is. Are there any questions on that? It is difficult to generalize all errors beyond this because there's a lot of things that we can mess up. So you just do the best with what you can. But what I've settled on is starting with the bottom line there. Any questions? Okay. If not, it's been a little over an hour. I think let's go ahead and take a break. 10-minute break. Yeah, we can round it. 12-minute break. It's almost 11:10 here. Let's come back at 11:20 Central Time. Okay, everybody, we'll be back in about 20 minutes. I'm going to step out briefly, but if you have questions meanwhile, feel free to put them in chat, and I'll answer them when I get back. So see you all in about 12 minutes. Okay, everybody, it is 11:20 Central Time. Let's go ahead and get started up again. Yeah, okay. All right, so we left off after talking about data types and operators and errors. Let's now talk about variables and functions. So, if you're coming from other programming languages, you know what these are basically already, but let's go over some of the basics really quick and see how they look in Python. So variables store data. So far, we've been typing out literal strings and numbers and whatnot, but more often in programming, you're going to be storing them inside something else, a variable, and then reusing the variable. Now, important thing about Python, variables are dynamically typed. This means that they can be defined and redefined very easily, very quickly and loosely. So just try running this cell here. We're defining this variable x equals 5. That's with 1 equal sign. Remember, the double equals was just the the equality check earlier. The variable is just assigned with a single equal sign. And unlike in some other languages, you don't have to declare like what type it is. It's not like int x equals 5. It's just the label and the data you want in it. And then you can use it just like that data. And you can reassign it very easily. So run the cell. You see we did x equals 5, the integer, and we printed x plus 20. That's just integer addition, and we got 25. But then we were able to just reassign it with no particular fanfare to a string, the string 5, and then do concatenation with 5 and the string 20 to get 520. This is one of my favorite things about Python, just the flexibility of the variables. You don't have to keep track of what type it is, which I suppose could be a drawback because you can more easily like accidentally turn it into something else, which might mess you up later on, but personal preference, I guess. Looking ahead again, for some of the Python extensions, you can get like data structures where you do get locked into a particular data type, but we're not going to see that today. That'll be like when we get into NumPy and pandas for data science, I think in the next class. For today, though, variables are just very flexible all the time, which I think is neat. Now, one thing to note, working in Jupyter, and you have all these discrete cells, right? Anything you define in one cell is persistent across the other cells. So you can reuse the variable from one cell in later cells, including doing the cells out of order. So here I have my int equals 8. Execute the cell, and note that it did not print out anything. That's normal. If you're just assigning a variable, it doesn't give you output. Once I set this variable, though, I can use it in this next cell. Print out my int, it prints out 8. Cool. Down here, I will reassign that, that variable to a string. Again, no output. Go back up and run this other cell, and it prints out the new value of the variable. This is different, I believe, than like if you do R Markdown notebooks. Because if I recall correctly, R Markdown notebooks have a sort of similar cell structure, but whatever you define in one doesn't carry over. You'd have to like do fancy things to define it in the background. Here, everything carries over. Zoom setup first again. Okay. So variables store data, and I like to think by comparison that functions store operations. So you can do more complicated things than, you know, add, subtract, int, not, the basic things we did earlier. You can, of course, define your own functions in Python, but we're not going to get into that today. We're just going to be sticking with built-ins for today. We have seen a function already. That's what the print function was doing, that print parentheses construct. This is the gist of how other functions look. You do the name of the function, and then you put something inside the parentheses, or possibly not. Whatever's inside the parentheses is the argument. And usually the function will do something with the argument to produce some kind of output. So this all down here shows a couple more examples. Again, inside print statements, which we've seen before. What's new is the type and len functions. Type gives you the type of whatever you pass to it. When you get into more complicated programming, you may not be passing it, you know, literals like this. More often you'll be passing it some other variables, but this is just to demonstrate what it's doing. And the len function, len short for length, tells you how big something like a string is. So if I execute this cell, I'm told that 2.9 is of class float, and howdy is length 5. That's 1, 2, 3, 4, 5. Yeah. Okay. So in these cases here, 2.9 was the argument to type, and type 2.9 was the argument to print. The string howdy was the argument to len, and len howdy was the argument to the second print statement. If the function sends you something back, that's called a return. So this is kind of a weird point. There's a difference between a return and whatever shows up in this like output here. I think I'll talk. Oh yeah, that's coming up in just a moment here. As a basic example, say that we assign the variable x is -10, and let's pass it to the abs function. This is short for absolute value. So absolute value of -10 should be 10, right? So abs x, that is abs of -10, should pass off 10 to this new variable y here, and then we print that out. Do we get 10 at the end? Yes, we do. Very cool. So now the weird sort of wrinkle here, the print statement, which I kind of don't want to talk about, but people are definitely going to run into it, so I should mention it. You may think print has a return because it sends stuff to the output. Print actually does not have a return. Sending stuff to the output is like, it's what the function itself does. It's not passing it back to you. So if you ever think that you want to assign print to a return, you probably don't. Let's see what happens when we do that. The output of this cell is 2, none. What does that mean? What's this none? What happened here is the print statement does what this first print statement, it did what the print statement does, which is send stuff to the output. So it sends 1 plus 1, that is 2, to the output. But then the return of print itself was assigned to z. And then we print out z, and that's none, because print returns nothing, which is actually its own type, this none type. There's not usually like use to this. I just want to point it out because people oftentimes do assign print to something and then get confused when they print out the result and it's nothing. More often here, what you probably would have meant to do is just to assign like the operation to your variable and then just print that. Takeaway is don't assign print statements to variables because usually that's not what you want. I don't know if I'm explaining this really clearly, but I want you to be aware of it because people do tend to run into it. Are there any questions on that? I apologize if I've not been real clear on it. There are, of course, other functions that don't return anything. We might run into some of those later. I think in the next notebook, yeah, we have some. We'll see more when we talk about methods, I think. Okay, let's move on meanwhile. If you want to know more about the given function, you can pass it to yet another function, the help function. This is like the built-in Python way to do it. So if you want to know more about the print function in particular, we pass print as the argument to help. And note the print function itself here will not get the parentheses. It'll just be the name itself. And this tells us what the print does. Shows you like the kind of arguments it expects, some details about them, says what it does. Prints the values to a stream or std out. This is describing, in this case, sending it to like an output cell here. There's other ways to find more information about functions and other things. Some of them will depend on your like interface though. So like here you can do tab. So I type the print function and hit tab and I get this pop-up here. This will kind of depend on your environment that you're that you're running in though. And we discovered last time some people do the same tab thing and don't even get this like extra documentation over here. And honestly, I don't know what that is. This sounds like a cop-out, but oftentimes if you want to know more about a function, there's always search engines. You can find helpful examples that way. They're very handy. If though you're ever stuck with just Python, the help function is always there. That's like the Python built-in. Pardon me. Okay. Let's do an example here. This one's going to combine a bunch of things. I want you all to make a little like 2-number addition calculator sort of things. First of all, I'm introducing another function for you too, the input function. Input's a fun one because you run the cell, it's going to pause execution and wait for you to give it something, to type in something, and then it'll pass it on as its own return. So we're going to like determine what the return for input is once we execute this. Let's go ahead and run this cell first. I execute the cell, and now first of all, you see on the left here, instead of a number, we have this asterisk. That's Jupyter speak for this cell is running. In this case, it's going to run forever until I give it some input. But if you do like some, big long running code, you'll see an asterisk here just to indicate that's the cell that's being worked on. Or rather, the cells in the queue. You can't have multiple cells like queued up at once. For now, though, we can be merciful and let it continue. Enter a number 8. Enter. Okay, and now it's completed execution. So I typed in the number 8, and input passed off as its return the 8 that I gave it. So 8 is assigned to X, and then I use that in the print statement here. The number is X, the number is 8. I want you all to, I guess if you want, make a copy of the cell, and then edit it to do these things. Ask for 2 numbers, or ask for a number twice, and print out the sum of those numbers. I'll forewarn, you will probably need these other functions, int and float. And you can find out more about those using the help function or whatever other methods you want. And so the goal is to make it ask for 2 numbers and print out the sum. I'll give you all a couple minutes for this. Go ahead and work on that and let me know if you have questions. Okay. How are y'all doing? I suspect there's one particular problem that y'all ran into first. I was at least work up to that point myself. So what we wanted was to get 2 numbers, right? So let's just do this first part twice. X equals enter number. Let's just get another variable with another input statement. Enter another number. For formatting reasons, I will put a colon space there just to make it look nice. Maybe some more spaces on this one so they're equal. And then I will print out X plus Y. If I run this, okay, enter a number, 5, enter another number, 10. And I get 510. Uh-oh, that's not math. How do I fix this? Okay. Chelsea put something in chat. That looks good. I will copy that over and give it a shot. So similar to what I did, X is an input, Y is another input, and then Chelsea used the int functions here in the final print. So enter number 5, enter another number of 10. Some of these numbers is 15. Yes, very good. So what was the issue here? The issue was that we passed something to input, right? But input returns a string. That is, like, even if we give it numbers, it returns the string versions of those numbers. So what I did here in my cell first, X plus Y, well, the plus sum between 2 strings is concatenation. So it concatenated 5 and 10 to get 510, the string 510. What we wanted to do was math, though. So we had to change it into some kind of number to make it work, which is what Chelsea did here. Instead of giving the plus operator 2 strings, she used the int function to turn them into numbers, to do number things to numbers. There's other things you could have done here. You could have made them floats instead, in place of ints. Because floats are also math. It gives you a float result. You could also have done those numerical conversions up here on the input statements. So like int input, like this. So now those variables are assigned integers in the first place. Where specifically you do those conversions and how you set this up, that's of course up to you. Does this make sense to everybody? Any questions? not, then let's go on to control structures, which I've hinted at a couple times already, I think. So we need to do fancy things. We want loops and if statements. Let's talk about what those are like. Sort of the key point of this section, and this is something I hinted at the beginning, is that white space is important. In other languages, white space is almost always stylistic. In Python, the white space is what marks that some chunk of code belongs to a given control structure. So for example, if you're using a control statement, it'll look something like this. You have some Python code up here. Then you have a control statement like an if or for loop or something. And instead of wrapping the relevant code for that loop or other control statement inside of like parentheses or square brace or curly braces or something, you just indent whatever's part of that statement. So this block 2 here. This is everything that is gated by the control statement. And once you're done with the control statement, the way you pardon me. All you do to indicate that you're done with the control statement is to get rid of that indentation. So block 3 here now has nothing to do with the control statement. And again, the only difference is the lack of indentation, the lack of white space. There's no closing curly brace or something. So let's start off with for loops. For loops are probably the most widely used loop in Python. I have used while loops a couple times. I use for loops all the time. Like, it's the main Python loop in my experience. The for statement has syntax like this: for some variable name in some iterable. And the greater than less than symbols aren't in there. That's just to indicate to replace these. You end the line with a colon, and again, no open brackets or anything, because it's all going to be identified by indentation after that line. We've seen the keyword in before. Remember when we were checking for like substrings? We use it again here to separate the variable name and the iterable expression. The iterable is going to provide like some list of things, and over excuse me, and over each iteration of the loop, the variable is going to take like each of those things. So for example, here's a really simple for loop: for thing in ABC, the strings ABC. This particular construct here is called a tuple, which I haven't mentioned. We'll see some more of these going ahead. I hope it's fairly clear that it's just like some list of things, though, right? It's a list of 3 things. So we're going to go through this loop, and thing is going to become each of these things. Let's execute this. Okay, so we printed out ABC. We've only got this one print statement in here, print thing. Well, for the, we have 3 loops, one where thing is A, one where thing is B, and one thing is C. So we print out each of them. Now, oftentimes, silence this. Now, oftentimes in for loops, you're going to specify like numerically how many loops you want, and that will often be done with this range function. I think we'll see a little bit more about that particular function later, but oftentimes you're going to have a construct that looks like this: for variable name in range count, where count is some number specifying how many loops you want. So in this cell down here, we have for x in range 5, printing x. If we execute this, we get 5 loops. Now, important to note here, in case you're coming from other languages, Python is 0 indexed. So we asked for a range of 5 numbers, and we got 5 numbers, but it starts at 0. So it's 0, 1, 2, 3, 4. Just be aware that if you're coming from like R or something, which is 1 index instead, or MATLAB or whatever. Note that variables outside a loop can be affected by operations inside a loop. So here's another for x in range 5, but before the loop, outside the loop, we set this total variable at 0, And over the iterations of the loop, we're going to be adding 1 to that total variable. And then at the end, outside the loop, you know that it's outside because it's not indented anymore. We're going to print total at the end. And you see it's gone from 0 to 5. Because over 5 loops, it added 1. So 0 plus 1 5 times is 5. Y'all try something more complicated now. It'll look similar to this, but with a little bit more. Do a little, like a little dummy compound interest loop. Create an account variable starting at 0 or whatever, and choose an interest rate. And over a couple loops, like in here, you're going to add interest to your account and then print out the total at the end. No particular endpoint, just make sure it works. So like start with a framework like this if you want, and do this calculation a couple times. I'll give you all a minute or two for this. Let me know if you have questions. Okay, how y'all doing? Anyone run into trouble? Anyone want to share what they did? I've started a dummy outline here, but if y'all have anything interesting, I can try pasting it in instead. Okay, so what I might do here, arbitrary numbers. Say I have an account of arbitrary items with value 100 and an interest rate of 0.02. I'm going to say for time step in range 10, so it'll do it 10 times. I'm not even going to use time step. I don't have to. I will calculate the interest as the account times my, oops, I did a dumb thing. Variable names should not have spaces in them. Interest underscore rate. There we go. Calculate my interest as the account times the interest rate, and the account is going to be account plus interest. Actually, I think we found last time, you could also do plus equals as shorthand. Account plus equals interest is the same as account equals account plus interest. I know some other languages do that kind of thing as well. So let's run this. And this is my final amount down here. If I wanted, I could print out the account each step along the way. Let's annotate it as well. You know what? Yeah, I can use the time step variable in here now. I get that right? Yeah. Yeah, there we go. So now you can see the interest being added over each step and then the final one. Are there any questions on this? And again, you could have reorganized this some other way if you want. You could have just done like instead of having a separate interest variable, you could have just put that on this line here. You do it all at once. Same thing. Okay, let's keep moving. You can iterate over strings because strings are a collection of things, right? Collection of characters. That can be your iterable in the for statement. So this cell down here, for C in hello world, print C. It just prints out each of the individual characters in that full string. You'll do something similar. You know the cheerleading pattern, give me a letter, give me a letter, give me a letter. What's that spell? Do that in Python. It'll be similar to this cell up here. So give it a word. You could use the input function to ask for a word if you wanted, and print out a message like, give me a letter. And then finally print out what's that spell and then the word again. I'll give you all another minute for that. Okay. So here I've done it myself. Here I just said a word directly, hamburger, why not? And then similar construct to what we had before for C in Word. And then I just used the C in a print statement with give me a. And then finally outside the loop, again, no indentation. What's that spell? Print word. So get each letter. What's that spell? Hamburger. Okay. Let's keep moving. Let's see. I want to finish this notebook before lunch. We're going to break for lunch at 12:30. Okay, let's just do these last couple cells really quick before one more break. Then we'll come back once more before lunch. Tuple iterable. This is something I showed before, in fact. You can create an arbitrary sequence of values for your loop just by putting things in a tuple. That is, just like surrounding them or separating them with commas. I think earlier I had parentheses around them as well. You don't have to. But you can just say for variable name in arbitrary list of things of whatever type you want. So here, for item in the string banana, number 100, Boolean false, print item. It just prints them all out. Easy peasy. Yeah, let's do this last exercise before we break again. In this cell here, do something similar to what we had here, but also print out the type of the item. That is both print the item and the type of the item together. I'll give you all like 30 seconds for this. 30 estimated seconds. Okay, I wasn't actually counting. Did you all get it? And can you help me figure out why I didn't get it? Can anyone tell what my error is? Yeah, y'all got it. So missing parent. In this case, the error message is pretty helpful, actually. It points to exactly where the problem is. There's supposed to be a parent there, and there's not. Because I closed out the parent for my type here, but not for the print. There we go. That does it. So I just had it print out two things each loop, pass them both to the single print statement, item and type item, banana is a string, hundreds an int, false is a Boolean. Okay. Cool. It's about noon here. Let's go ahead and take one more break. This is a small break. We're going to come back briefly after the break and have one more small section before breaking for lunch again. So, Victor, if you can put up the waiting slide again, we'll come back at 12:10 Central Time. And then hopefully in that brief section, we can finish up the notebook, and then we'll break for lunch after that. Just one more small break for now. Okay. It is 12:10. Let's go ahead and finish out this notebook. Should go relatively quickly. And then once we're done with this, we'll break for lunch and then move on to our second notebook once we come back from lunch. Okay, so we're talking about loops. Now let's keep going. Let's talk a little bit more about the range iterable. So remember, we've been using range to for x in range number to go through a list of numbers. The range function can take some additional parameters to determine exactly what that set of numbers is. It doesn't have to be 0, 1, 2, 3, etc. As shown in this markdown cell up here, you can give it either just the stopping number, like we've done before. It'll go from 0 to 1 before the stop. You can give it two numbers to be both a starting point and a stopping point, so you don't have to start at 0. Or you can give it a third argument as well to determine the spacing between each of the steps in the loop. So let's do this exercise here, range sequence. Create a loop with a sequence of the even teens, that is numbers between 13 and 19. So let's just go ahead and do this together to make sure we can get through it. For x in range something, we're going to print the number, and the words is even. So x will be a number, and let's just concatenate the string is even. So we're going to be iterating by more than just one. So we're skipping some numbers. We're probably going to need the step variable. So we're going to do three things. We want numbers between 13 and 19. So those will be our first two numbers. These are the start and stop values. And then we want to, since we're going to be skipping one, skipping the odds, we do 2. Does this get it? Oops, I did it again. X is a number, and I tried to attach it to a string somehow, but I can't do that. So I could either turn the X into a string to concatenate, or just do like comma separation to pass multiple things to print. Did I get it right? Uh-oh, I didn't quite get it right. Probably we should just start on an even number and then iterate by 2. And since the last one isn't included, we can bump the 19 up to 20, and we know we're not going to hit 20 because it's not included. There we go. 14 is even, 16 is even, 18 is even. That makes sense? Anybody have questions? I could demonstrate the range stepping stuff more plainly, perhaps. For x in range, let's just say 0 to 50. Let's do a step size of 3. Why not? Oh, wow, I did nothing. Wow. Print x. There we go. Okay. So you see it started at 0, like I told it to. Increments by 3 up until it would pass over 50. Change the step to 10. That's a good way to show it. Note that it does not include the last one again, because it starts at 0. Okay. I might skip some of these, leave them as an exercise for the reader. Yeah. I want to hit some of the big points before we break again for lunch. Let's talk about nested loops. So you can have a loop inside of a loop. Remember how we identified that code as part of a loop, we indent it, right? If you put another control statement inside something that's a loop, you just indent the code further to indicate that you're part of that inner loop. So like we have here, for statement code, which is indented, and then a for statement inside that for statement. Second for statement is indented just like the other code inside the first one, and then everything inside the second one is indented even further. Now remember that the general for syntax is for variable name in iterable, like this, right? When you're nesting stuff, Python will not complain if you reuse the variable name, but generally you don't want to do that. In my experience, that's only ever confusing. So usually you'll want to do something like for x in, for y in, or just any different set of variable names. Because again, Python won't stop you from doing that. It's just you're probably going to mess yourself up doing that. Usually that's not what you intend to do. So in this exercise here, create a loop over an arithmetic sequence that prints the loop variable. That is, make a loop that's counting up 0, 1, 2, 3, etc. And then nest that loop inside another loop that repeats 3 times and see what the result is. And then switch them if you want. Y'all go ahead and try this. I will go ahead and start typing my solution as well. Okay. So here's what I've got. It said to create an arithmetic sequence loop and put that inside another loop that repeats 3 times. So the outermost loop is the repeating 3 times. I put for iteration in range 3. Inside that loop, I'm going to go ahead and print what iteration I'm on. I put some asterisks in there just so it stands out visually in the output. And then the second loop, again, this second for is indented, so it's inside the first one. I'm doing for I in range 5, just printing I. Let's run this. And what do we get? Okay. We see it went through the inner loop 5 times. We have 0, 1, 2, 3, 4, 3 times, and they're separated by this print statement I made up here with the asterisk, indicating what outer iterations is. So we have an iteration 0, iteration 1, iteration 2. The third line up here in the exercise suggested that we switch them. Let's try that out. I will make the for I in range 5 the outer one, and the for iteration the inner one. Now that I've swapped them, we're now doing the thing with the asterisks 5 times. So 0 from the outer loop, and then asterisk 0, 1, 2. Then 1 from the outer loop, asterisk 0, 1, 2, etc. Are there any questions on this? Did anyone run into trouble with this? Oh, and then lastly, of course, if you want to do something outside the loop, just get rid of all indentation. The final thing with no indentation will just happen once at the end. Okay. I'm going to skip this multiple loop variables part. I don't think we're going to come back to it today. Let's talk about conditionals. These are important. They deserve at least these last 10 minutes before lunch. So remember those Booleans. Booleans are very useful for determining if we should do something. Keyword if, literally keyword if. If you're coming from other languages, you probably know what if statements are already. We're going to pass some expression to if, and then just like with the for loop, the code that is controlled by the if is going to be inside some indented block like this. Again, just like with the fors. See this pre-written example already. This code is going to check if two variables are the same as one another. var1, var2, use the double equals, so it'll return a Boolean. If it's true, it'll print a match. That is the stuff that's indented. And no matter what happens, it'll print the end. So the question is, will it print a match? Let's just put two numbers in here, 7 and 7. If 7 equals 7, then it'll print a match the end. And it did. Very good. Let's do different things. How about 7.1? Is that equal to 7? It is not, so it skipped a match and it just printed the end. This pre-written code is all down here, checking if 1 is less than 99, but it didn't work. How come? Y'all ready for lunch? Okay, yeah, no indented line after if statement. So yeah, in this case, it's got a name for it, indentation error. Expected an indented block after if statement on line 2. That makes sense. Let's indent. And there it goes, it works. We can make this false, of course, and then it wouldn't print it, but also no error. Because failing the test here isn't an error, it's just the Boolean false. Okay. It's a little bit more, I'm going to scroll down a bit. Pardon. To add a little bit more to the if statements. You can do more fine-tuned things than just, if expression do this. We've also got else statements and elif statements. I'm going to scroll back up here, actually, because this is a little bit simpler. Up here, we just have this one if statement for if the variable was less than 99. We could also do an else for the other option. Else doesn't take another argument. It's just what happens if none of the other if statements did. In this case, since it's kind of a binary choice, well, almost. We'll assume that if it's not less than, then it's greater than. So here is 100 less than 99. No, it fails this first if statement, but it should then, or well, it doesn't check. Since it failed this first statement, it'll do what the else says, which is that it's greater. However, there's a third case here. It doesn't have to be greater than or less than, right? It could be equal to. This is a case where an elif statement would come in. Elif's like a combination of if and else, or well, it's a combination of else and if, of course. Say we have var equals to 99. And we'll print that they are equal. So what happened here is, in this case, we're comparing 199. This first if statement, its condition fails. So it proceeds to the elif statement and checks if this is true. In this case, this is also not true because it's 199. And since neither of these passed, then it will do the else at the end. So we get var, that is 100 is greater than 99. Let's check that we got it right if it is 99 though. So it's not less than, so it won't do this. It does satisfy this elif statement though. Okay, and so it printed out that they're equal. And then it didn't do the else because something before the else passed successfully. Okay, and this statement down here is similar, but it does user input. From this cell, it's an input function. Do you like soup? I will say yes. And it tells me good soup because input passes its return to var, and the var that I gave it was yes. So it prints out just this, and then like it skips the rest because it already passed this statement. If I did no, that would not match the if statement, but it would match the subsequent elif statements. So it prints out too bad instead. And then the else statement, which doesn't have its own test, this is sort of like the catch-all for everything else. Maybe. And it prints out this final line, I only understand yes or no. Any questions on right? Any questions on if, elif, else? I will acknowledge that jumping between languages, I always forget if it's elif or else if. So no shame if you forget as well. Python is elif though, the single word elif. Okay. Jumping down a little bit, I do want to show off this one. You can combine your conditionals with other operators. Most of what we did up here was like math and these equality things. Remember the in operator and the not operator? This cell down here is using both of those. Again, for more string checking, but like if it returns a Boolean, it's fair game for the if statement. So even something kind of complicated like this works. What flavor of ice cream do you like? Chocolate. Okay. Since the thing that I said is in ice cream flavors, this string up here, this first if conditional did not trigger because it's looking for not in. So it did the else instead. You got it, whatever coming up. If I did choose something that was not in that though, orange, then now this statement is true and it executes the stuff in that block. Okay. In the few minutes we have left, yeah, sort of two things to show, I guess. We did nested loops before, right? You just increase the indent. You can do the same thing with if statements. In this case, nesting ifs. So here you've got one overarching if with its own if and else inside of it, and then an outerlying elif and else which don't have their own nesting. Again, what defines what block they're part of is their indentation. So this secondary if and else is only considered if this first if statement happens. In this case, flower petals is 5. If flower petals greater than 0, okay, that's true. So now we're considering these. If it is divisible by 2, you print this statement. Else, which is what happened here because 5 is not divisible by 2, you print this statement, which is what happened here. If you don't satisfy this initial if condition, then this nested stuff doesn't happen. So let's put in 0. First one doesn't trigger, second one does. Or if it's something that is none of those things, flower with negative 200 petals, something's wrong with this flower. It skipped these things because none of the conditionals are true, and it does the else instead. Okay, we have 1 minute left before break. Oh, speaking of break, the thing I want to show you is the break statement. You can satisfy condition and then immediately jump out of your loop. This can be dangerous, but I want to show you it's possible. Here we have a loop that would print numbers normally. Actually, let's go with comments breakout. What this loop does by itself is print 1, 2, 3, because it's range 1 to 4, right? The break statement, though, will immediately jump you out of the loop. So it prints 1 and then stops. Sometimes this is useful. Some people would tell you that it's better to maybe have an if statement in here such that you can programmatically check for a condition instead of arbitrarily breaking like this. Sometimes this is the best way to do it, though, so at least be aware of it. Okay. It is now 12:30. I don't want to keep you from lunch. We're about at the end here. Takeaway from the end, the break statement exists, and I know other languages have that, so if you use it elsewhere, it does the same thing here. Okay, let's go ahead and break for lunch. We'll break for about an hour. We will reconvene at 1:30 p.m. Central Time, and we'll get out of this notebook and move into the next one. If you joined us for our first class last time, this has all been mostly stuff you've seen before. The next notebook is all new things for you. So thank you for being patient, and hopefully the review helps. Otherwise, yeah, I'll see you all back in an hour. Have a good lunch. And Victor, if you're there, or whoever's there, please put up the lunch slide. Okay, everybody, it is 1:30 Central Time. About time to get up and going again. I'll give you all another minute to get set up, maybe, in case you're cleaning up from lunch. It's time to set up my Zoom interface again. Okay. So, before lunch, we went through the basic elements of coding in Python. We went up through these control structures, loops and conditionals and whatnot. We are now done with this notebook. So, if you want, you can save the notebook, hit the floppy disk icon or Control S or file save or whatever, and you can go ahead and close this tab for this first notebook. Navigate back to your Jupyter file browser. Looks like this. I mentioned before, but in case you closed out already, if you've lost this tab, you can reopen it by going to your portal tab and hitting connect to Jupyter again. If you've lost this particular page, find the portal and go to My Interactive Sessions, and the job you submitted in the morning should still be there. If somehow you've lost your job, you should just be able to submit it again from the interactive app menu. So, anyways, we have another file to go through. Everybody go ahead and open notebook number 2, data structures. And it'll look like this. Okay. So, this notebook is data structures. For when a single simple variable is not enough, we have ways to store a bunch of data together and get it back out and use them in batches. That's mostly what this notebook is going to be about. This will be very important to know if you go on to come back for our Python for Data Science course, which will do a lot of data structure type things similar to this. So we have already seen a couple things that can have varying lengths. So strings, right, can be any number of characters. Today we also talked about tuples very briefly. Those just like comma-separated list of items. We're now going to introduce 2 more data structures. And there exists more than just these 2, but we're going to focus just on these 2 for today. We're going to look at lists and dictionaries. So let's start off looking at list and dictionary literals. That is like how you would create them directly and what they look like directly. So lists, they'll kind of look like tuples, as we saw before. They're comma-separated lists, but they're going to be defined inside of square brackets. Each item inside of those brackets is called an element. The commas separate the elements. So, for example, here in this markdown cell, my list is the variable name, and we're manually creating this list with 3 elements in it: the strings apple, banana, orange. We have that down here under this example. So this is set up for you. It creates that example list, and it prints out a couple things about the list. Let's go ahead and run that. So the first thing we print is just the list itself. That's this top line here. Well, we print out this string example list and then list itself. And it looks basically the same as how it was first defined. The string, the apple, banana, orange, surrounded by square brackets. We can print out the type, and it tells us that's a list. It's a rectangle type, cool. And the length now is 3, because there's 3 elements in it. It's not like the length of the strings altogether or something. It's 3 comma-separated elements in this list. If we add something else to it, for example, Kiwi. Okay, print out list again. You see the change I made, still class list, and now it's length 4, because I added another comma-separated element. There's other ways to build lists. It's not always necessarily from scratch. You can, for example, concatenate 2 lists, similar to what we did with strings, right? Take 2 lists and just tack them on to the end of each other. Some non-list iterable objects can also be turned into lists using this list function here. Like think of what we did earlier in converting a string to an integer or a float. We just did like int float function. Similar here, there's a list function. You can try these out in this cell down here. You've got 2 lists created for you already. They both just have 3 numbers in them. We have a string and we have a tuple with 4 elements. Next to this comment here, y'all fiddle with these a bit. Try combining them together or like list converting them with this function here. I'll give y'all a minute or 2 to play around. Just make sure that you can create some new object that gets printed and looks like a list at the end. Okay. We will, of course, have more time to fiddle with these in the rest of the notebook. But just for example, I'll start simple myself. List 1 plus list 2. What does that get me? It gets me a single list that's just a combination of the elements of 1 and 2. Make sense? What if I reverse the order? Does that change it? List 2 plus list 1. Indeed, it did. Now we have 4, 5, 6, 1, 2, 3 instead of 1, 2, 3, 4, 5, 6. What else can we do? Can we add list 2 and string 1? Does it let us? No, it doesn't like it. Jump to the bottom, it says type error can only concatenate list, not string to list. Okay, so I cannot mix up strings and lists. How about I just turn that string into a list then, using that list function. So list 2 plus list with string 1 as the argument. And that worked. What did it do? So we have 4, 5, 6 from list 2, right? And then it turned the string into a list of individual characters, like 1 by 1, including spaces. This might be easier to see if I did tuple 1 here instead of string 1. Yeah, that's a little more readable. If I just did list 2 plus tuple 1, I get the same issue that I had with the string. Type error, don't mix up the types. So if I do turn it into a list, that works, and it combines like what you'd expect. List 2 is the first 3, and the 4 elements of the tuple. Any questions on that? We're going to come back in a minute to do more with lists. I'm going to introduce the second data type first, though. Any immediate questions on what we've seen of lists? Okay, then let's keep going. As I said before, as we go along, we'll introduce new ways for things to go wrong, and new opportunities for questions. For now, let's talk about dictionaries, the second data, the second like compound data type we're going to talk about today. So lists were, the problem with them being called lists is that now I can't use the word list to describe them. Lists were collections of objects, right, comma separated. Dictionaries now are collections of pairs of things. Whereas lists just had individual elements, dictionaries are now going to have key value pairs. So like in this little table here, if this were a dictionary, the first entry of the dictionary, the first singular entry of the dictionary would be both key 1 and value 1 together. And then the second entry is key 2, value 2. The keys can be of almost any type, but they cannot be other data structures like dictionaries. There's a particular criteria here which we'll get to later. The value, though, in the key value pair can be anything, including other dictionaries. So earlier we nested if statements and nested loops, right? You can have nested dictionaries and nested lists as well. That's something I did a lot. I'll show you an example later on if we have time. How do you create a dictionary? Remember, the list was created with square brackets around the comma separated values, right? Now the key value pairs in a dictionary are separated by curly braces. Curly braces is a dictionary. And you separate the key and value with a colon. Each individual entry, though, again, in this case a pair, is separated by the comma still. So it'll look something like this. Variable name here is my dictionary, and this manually created dictionary surrounded by curly braces. This is the first entry, the string key 1 colon string value 1, comma for the second entry, which is string key 2 colon string value 2, and then etc. There can be more. Now this is frankly kind of a pain to look at. So luckily, we're able to split these up across multiple lines. Oftentimes in Python, if you do have something inside braces or parentheses or something, you can insert line breaks. So to make dictionaries like this more readable, you can have my dictionary equals open brace, and then on the next line, that same key value pair, comma, key value pair, comma, etc., and then the closing brace at the end. And most editors, when you do something like this, it'll automatically indent it for you, which I don't think is actually required in this case, but it's again helpful for legibility. So let's scroll down. See an example of a dictionary. This is similar to our list earlier. We have apple, banana, orange, but now those are just the keys in these 3 entries in this example dictionary, and they correspond to these numbers over here. So we go ahead and execute this cell. First of all, we're printing out example dict and that dict dictionary, and it looks a lot like what we defined it with in the first place, though when you print it out like this, it doesn't have line breaks. The type is class dict for dictionary, cool, and the length is 3. We put 6 things in there, but remember, it comes in pairs. It's 3 entries that each have 2 things within them. So again, if I add one more pair, we'll see the length only go up by 1. Kiwi, mix it up. Put a string in there. So I added one more key value pair. You see it show up here when you just print the dictionary, and the length is now 4 because I added one more pair. Okay, y'all take a minute, write your own lists and write your own dictionaries. And then you'll have these print statements at the end to double check that you set them up correctly. I'll give y'all just a moment here to practice putting in the syntax right. While you're at it, try putting silly things in the lists and dictionaries. See if you can break them in fun ways. I'll give y'all a minute to experiment. Okay. So here's the random things I've done. I've made a list with a mix of data types. I have 3 strings, 3 ints, and 3 booleans. And I was inconsistent in my spacing. That's fine. For the dictionary, meanwhile, I've put in 3 key value pairs, 2 with strings and numbers, and then the last one with a number again. Why not? Okay, execute cell, and it tells me, yes, I've made something of class list and something of class dict. So I've made a successful list in dictionary. As I mentioned above, once you're inside braces or brackets or something, you can do line breaks in case that helps with readability. So here in the case of the dictionary, run it again, didn't change anything. You can also do this with lists if you want. So you see I have, like, I've grouped my the elements in my list by type. If I wanted, like if this were a much longer list, for example, I could put these, I could put these all on separate lines, like just for my own sake for readability. And again, it still works if I execute the cell. Okay. Did anybody do anything silly? Did anyone break this in fun ways? Are there any questions? Okay. Let me know in chat if you have any questions along the way. Let's go ahead and talk about indices and keys. So we just made some lists in dictionaries. That's cool. We put a bunch of stuff into these variables. Now, how do we get them back out? How do we get like an individual element out instead of just printing out the entire list or dictionary again? This is what indices and keys are for. So we can use indices on several data types, including both lists and strings, and some other things that we'll talk about in later classes. The only thing that has keys at the moment, though, is going to be the dictionaries. The key is going to be like a more elaborate index, which we'll see in a minute here. We're going to start by practicing with strings because they're the simplest. We're going to start on indexing strings and then build up from there. So strings is a sequence of characters, right? How can you get individual characters out of them? So each character in the string has an implicit index to it, an implicit integer index, starting at 0. Again, remember, Python is 0 indexed. Other languages start at 1, Python is 0. So if you have this variable here, string 1, and you set it equal to the string apple, we'd say that the character A is at index 0, then P is at index 1, second P is at index 2, and 3, then 4. So remember the length function tells you how long it is. If you run length on any given string, it'll return a number that's 1 higher than the last index, again, because we're starting counting at 0. Fun thing in Python, which I don't recall seeing in other languages, if you pass a negative index, it'll just start counting from the end, which can be very handy. Like if you specifically want just the last character in the string or the last item in a list, as we'll see in a minute, then you can pass -1 in your indexing. So what do you do with the index? How do you pull these out? How do you make use of them? You're just going to put them inside square brackets at the end of the variable, in this case, indicating your string. So in this little example box down here, type in some string for string 1 here, like fill in these quotation marks I just put in. And then inside these brackets here on the second line, put in a number. That's your index. And it'll pull back out for you the corresponding character of that index. So you'll go ahead and try that for yourself. So here myself, I put in a word for string 1, haberdasher. I don't know why I thought of that. I believe that's the person who makes hats. And if I want to pull individual letters out of it, if I want the first letter, because it was 0 indexed, that'd be string 1, that is the name of the variable, string 1, and then that index 0 in brackets. Run the cell, I get H. That is the first letter. Yes, very good. Second letter would be space 1. That should be A. Yep. I mentioned negative indices. How about we do -1 to pull it off the end? R, yes, very good. I can do -2 to go 1 back from the end, etc. Let's see. Can we mess this up? Is -0 a thing? Just gives me the first one. -0 same as 0. Fine, fine. This now, of course, introduces a new way to do something wrong. What if I put in index 200? Index error. String index out of range. Yes, makes sense. I asked for the 200th character in a string that's not that long. This works if you're going negative as well. So -200 gives you the same error. Now, there's a little challenge here at the bottom of the cell. Can you find the middle character in a string without counting the characters yourself? Did anyone have a chance to try that? Actually, yeah, I'm going to give you all another minute. Try that out. See if you can find an automated way to get the middle character of a string. In particular, remember the len function, len, and integer division. Okay. Anybody have ideas on how you do this? Anybody? Almost there? Okay. I can give you all a little more time. Okay, I see a solution in chat. I'll let other people work on it for just another couple seconds. Yuhing, I'm going to copy your solution in here just to show it off. And change the string though. Okay, so here's what Yuhing did. So set up your string first, and then we assign the length of that string to this variable n, and then we're going to use that n integer divided by 2 when indexing the string again. So let's run this, and I do in fact get the middle letter here. If we were to change the string, still gets one of the middle 2 letters. Yeah. So this is something I didn't specifically show off, but like you can put an expression, anywhere. In this case, inside the indexing brackets. Thank you, Yuging, for sharing your solution. Does anybody have questions on that? One thing, I guess, note that you do specifically have to do integer division, because if you make it a float, you get this type error, because you cannot broadly index something with a float. There's no implicit float indices. It's all integers. What is the double slash for? That's for integer division in particular. Remember, if you do like 5 single divided by 2, that's like normal full division, and you get a float out, 2.5. 2 slashes, though, is integer division, and you just get 2 out. Like it truncates off the part that would be floating point to just get an integer. And it's for cases like this, when you specifically have to have an integer. Okay. So this was string indexing. It's going to be very similar now, jumping back to lists with list indexing. So now instead of individual characters having that implicit integer index, we now have individual elements, which could be, larger data objects. Those will each have their own integer index now. So if list 1 is equal to the 3 strings apple, orange, banana, the entire string apple is now at index 0, and orange is at 1, and banana is at 2. You use this index in the same way that we just did for strings. You put it inside square brackets at the end of the variable name of the list to index something out of that particular list. And once again, you can use negative indices to pull stuff from the end. So in this example here, we have this example list with 3 objects again of different types: the string Aggie, the floating point 1.0, and the the special none type. I mentioned briefly before, but like none is its own thing that sometimes can be useful, but we won't use a lot. So what happens when you index stuff? Try putting in indices in here and see how it returns the item and what the type of that item is. I'll give you a couple seconds to play with that. I guess, yeah, try pulling out that none object, see what it says about it. Okay, so here I put an index 0. That's the first object in the list, which is Aggie, the string. It prints out that item, the Aggie string, and it tells me it's a class string. Sure, fine. Do the second object at index 1, iterate float. It is a float, cool. And finally, the last object at space 2, none, class none type. None has its own type. Very nice. I didn't demonstrate this earlier, but so again, you have negative indices, right? It is literally the same thing. So instead of 2, I could have done -1, and it returns the same thing. In fact, if you do like, in this case, example list 2 equals like test for quality sample list -1, they're identical. The benefit of having these negative indices is that you don't have to know how big the list is to pull off the very last element. Like for an element that's only, for a list that's only 3 elements long, you know to get the last one to index 2. But if you're doing data science and you have, 347 entries, and you don't necessarily know that, you don't want to count them. So you use negative indices instead. Very handy. Okay, now, since we can identify individual elements to pull out, we can also identify individual elements to change. You can reassign individual members of a list using the same syntax that we've just been using to pull stuff out. List name, and then the index in square brackets. Variables that refer to that object will remain in place, but they will get updated with those new contents. Now make note, this is different than strings, as I will demonstrate here. So this first cell, we're going to replace element 0 with not an apple. The list starts as apple, banana, orange. We want to replace the first one. So now on the left side of our equal sign, if we want to replace the first element, we'll put in 0, because that's the one we're talking about. And you want to replace it with not an apple. And then print it out. Print out the list, that is the full list. And we see we have the full list except for that first element is now not an apple, the thing we gave it. You can do that for multiple elements, why not? iList, let's change the last one. Let's make it a different data type, why not? Put a Boolean in there. So I've made the first one not an apple and the last one false. not the string false. I changed the data type. It's a Boolean, not a string. Now, speaking of strings, though, you cannot do the same thing with strings. You cannot replace individual characters. So the second cell here, it's very similar to what we had in the previous cell with the list, but now instead of a list, it's a string. We have these quote unquote 3 elements. They're not really elements in this case. It's just a single string. They're all wrapped up in these double quotes instead of the brackets. Now we saw that we can index strings, right? That's what we did before the list. So let's try to change the first element to something else. Run this, and we get a type error. It says string object does not support item assignment. That is to say, like, it recognizes what we're trying to do. We're trying to assign a particular item within this iterable in the same way that we did with the list. But with strings, you cannot do that. This property is called mutability. If it's changeable, we say it's mutable. If an individual element is changeable, I should say, we say it's mutable. So lists and dictionaries are mutable objects. They can be edited in place, partially, or as a whole. That is, like I did in this first cell up here. I can grab a particular element and change just that element. Strings and tuples, meanwhile, are immutable. As we saw in the second cell here, those cannot be edited. If you want something different, you just have to make a whole new one each time. And if you remember back a couple minutes ago, when we were talking about dictionaries with keys and values, and I said that only some things can be keys. This is more directly the criterion that determines if something can be a key in a dictionary. It has to be something immutable. So you cannot make a list or a dictionary the key in a dictionary. It can't be the value, though. Values can be anything. It's just the keys that have this mutability restriction. Usually this doesn't come up, though, because I think most people use relatively simple objects for the dictionary keys. That's usually the point. We'll talk more about that in just a moment. Okay, you all play around a bit in this exercise. Create a list, put different data types in it, try changing those data types, and then print it out again to make sure it worked. Again, try to put something weird in it, try to break it. Let me know if you have any questions. I'll give you some time to experiment. Okay. So I'll do this myself really quick. Make a list. X is 11, 22, 33. Let's change the last element to fish and print X. Okay, and it works no problem. I turned an integer into a string, and it's fine. I mentioned this earlier. Later on, when we start adding extensions to Python, there will be some compound data types in which you cannot do this, in which they'll all have to be the same type. But we're not going to see that today. That'll be something we see in the data science class. For now, though, we're still flexible. Now, here's something. So before I go on, did anybody find anything weird in creating a list and changing elements? Any questions? Okay. Seeing none, let's talk about something kind of weird. I'm going to go ahead and do this, and you can follow along if you want, of course. I'm going to create a list. Let's do the same one I did a minute ago. And I'm going to create a new variable that is equal to the first one. So I set x equal to a list, and I set y equal to x. If we now print x and print y, so this all looks fine. It's about what you'd expect. X is 11, 22, 33, and y is x. We print x, we print y, we see the same thing twice. Let's now change something in x. X, let's just change the first one. X index 0 is equal to hello world. Print x and print y again. What's going to happen? Let's run it. Okay, so the first two print statements, again, did what we thought because I didn't change that. 11, 22, 33 for both of them. But now, I only changed x. But when I print x and y, they both have changed. This first one is x. This is the first print statement at the bottom here. And print y, the second one has also changed, even though I didn't change y. So if you're familiar with like C++ or something, you may be familiar with pointers. That's kind of what's happening here. Y is sort of a pointer to x. If you're not familiar with pointers, that's fine. Just be aware of this behavior. Some of these, like some of the compound data types, like what's happening in the background is it gets created once in memory, and then you can just have multiple things pointing to it. And if you change that underlying thing, then everything pointing to it will change. Actually, yeah, so if I, instead of changing x, I change y instead, you see x also got updated. Because again, the list lives in some particular memory spot. And when we change that memory spot through any entryway, all the entryways see it. Now this is unique to these data structures. Normal variables won't do this. And you can also break this behavior if you don't like it. We'll see that later. There is a way to set y to be a separate copy of x instead of literally the same object in memory. For now, just be aware of this. Okay, side note. This is dumb, silly stuff. You could put x inside of itself, and Python will be okay with it, question mark. It'll kind of nest it. You can get weird behavior that way, though. I don't recommend this. I just want to show you that's what happens. Yeah, let's not dwell on that. Okay. Let's move on to dictionaries and keys, because I think this is really neat. This is something I really like that Python has, but I've not seen in a bunch of other languages. So what we did with the strings and lists, right? We indexed them with 0, 1, 2, 3, etc. And you may have wondered before, what's the point of dictionary keys? Why do we need these values? The keys now are going to be how we index a dictionary. You can now customize how you pull stuff out of a dictionary or even put stuff into it. So if you want to retrieve a value, for example, you'll give the name of your dictionary and then the key inside of the square brackets instead of the integer 0, 1, 2, 3, etc. You can likewise create a value, like similar to how we just assigned and changed values with lists appear, in the same way. Dictionary name and then the key inside square brackets, just assign a new value. So here, again, this is all spelled out for you already. We have an example dictionary, apple, banana, orange again, with excuse me, apple, banana, orange being the keys, each with corresponding values. And you can fill in a key here to choose which one you want to get out. Apple is pre-filled already. If I run the cell, is printing key and then the key, so key apple, sure, and then item, the item that we got by indexing with that key, and apple was the key for the number 11, so we get that out. Change it to, say, orange, and we better get 0 out, right? And we did. Very cool. Again, let's add another entry, kiwi, or whatever you want, equal to this big thing. Specify that with my key, and I get that big number out again. As I mentioned above, you can also use this syntax to add values. So in this cell down here, we're manually creating an empty dictionary. You see this variable new dict equals to curly braces with nothing in it. That's allowed. You could also similarly make an empty list if you wanted with just empty square braces. But we have this empty dictionary. What good is that? Well, let's add stuff to it. If we want to add something with key blue and value 7, you do it like this. You do this sort of like indexing syntax with the key you want, and then just set it equal to whatever you want. And then similarly down here, add an integer index if you want. You could do the same 0, 1, 2, 3 you had with list if you want. Go ahead and do this. So we had 3 print statements. First one is printing out the empty dictionary, and indeed, that's what we see, empty braces again. Then we added a new key value pair, blue 7, prints it out. You see that? And then lastly, another key value pair with 11 false. You see that again. So you'll try this out. Make a dictionary. You can make it empty or make it with stuff filled in already. Then try growing the dictionary. Add some new key value pairs. Try replacing key value pairs in there already. Try different data types. If you want, try nesting dictionaries like I mentioned before. And I'll show you an example of that in a minute. Yeah, this is free time. Go ahead and try this out for a minute or two. Create some weird dictionaries. Get used to the syntax and see how it breaks. I'll call you back in just a minute or two. Okay, so what I have done is do some nested dictionary nonsense. So my background is in particle physics. I did a bunch of physics simulations, and I said I liked nesting dictionaries, and I like dictionaries. This is kind of why. So what I like about dictionaries is that you can make the thing you can make the thing that you use to index have meaning to it. If you're doing a list, you have 0, 1, 2, 3. Okay, the order's straightforward, but like, do you remember what item 23 is? Do you remember why it's there? With dictionaries, you can provide like keys that mean something. So in my case, if I'm doing particle physics simulations, I can put in a key called neutrons for a neutron simulation, say, or protons for a proton simulation. And then within those, I can have keys for like a given configuration or something. Or if I have multiple runs, I can name them useful things. And so then I can index them by providing names that like mean something, and I don't have to remember the order they're in. So if I know that I want, the protons simulation, configuration B, say, I can pass specifically those keys and get out exactly that thing. I don't have to remember that it was, simulation 2, setup 5, or whatever. What do those numbers mean? I admit this is kind of hard to read, but again, this is why I like the dictionaries. This could have just been only numbers, but instead it's got useful text in there. Okay, are there any questions on this dictionary stuff? Everyone okay with putting stuff in and pulling stuff out? Is there a way to get your dictionary to print in more of a table format? In base Python, I don't think so. Other folks, feel free to correct me if I'm wrong. Next time when we get into the data science stuff, there will be some more add-ons that let you print stuff out more readably. Like I don't think this works. Oh, well, kind of. So changing print to display helped a little bit. Next time though, when we start talking about the pandas library, pandas is like built for 2D tabular data. And when you display some of those pandas objects, then you'll get like a nice, very readable table with like headers and row indices and whatnot. For right now, with just plain dictionaries and just plain Python, though, I don't think they have a nice way to print it out like that. Okay. So this, yeah, we got about 10 minutes until the next break, I think. I think we can get through slicing, and then we'll take a break after that. So what we've been doing so far is pulling out individual elements, right? Or setting individual elements. We can also pull out multiple elements at once, and that's called slicing. Again, we'll start with strings and then work our way back up from there. If you want to pull out multiple characters from a string, you'll use syntax like this. So string name, and then inside your square brackets, where we used to have just one single index, you'll have 2 indices separated by a colon, indicating where you start and where you stop. So here we have test string equal to test string, and we're going to slice out these indices here, 3 up through 6. It leaves off the last one. And we end up with T space ST, which is these bits here. So again, you can count with me if you want. The original T is at index 0, then 1, 2, 3, where we start slicing is the first T. 4 is the space, 5 is the S, 6 is the T, and then you stop before the specified stopping point. Or like remember 0 is the very beginning, right? Change the first one to 0, which starts at the beginning until the specified endpoint. You could also, again, use negative indices in here. So let's do like -5, 0 to -5, test space S. So a couple notes, which I think I said already. The character at the stop position is not included. The one at the beginning is, just not the end. You can also leave one of those blank and just leave the colon in there, and it'll pull everything on that side. So in fact, up here, I didn't have to put in a 0, colon, etc. I could have just left that blank and it would do the same thing. So this is saying like everything up to the -5 index. And you can do that the same from the other side as well. Let's get from index 4 to blank. That is 4 to the end. You get a string. So you could leave off both and you just get the whole string because it's everything from the front to everything to the back. There may not normally be much reason to do that, but that's how it works. Good to know. Note as well, you can also provide a third number in there after a second colon to choose how you want to step across something. Let's just put this back in. So if I do 1 to say -2 and add a colon, colon steps at 2, we get ETSR, which is starting from index, starting from index 1 and steps 2, E, T. Maybe I shouldn't have been doing this on the fly. Let's go from the beginning. T, E, S. Oh, wow. I'm looking at the wrong thing. Starting at 0, T, step by 2 to here, step by 2 to here, step by 2 to here, step by 2 to here. Okay, yes, that works. I was looking at the literal variable name instead of the string. Silly me. Okay. Just a demo. Let's get the full string in steps of like 5. Yeah, big jumps, not that many letters. Okay. You'll try it out yourself instead of watching me ramble. We've got an example string in here. Change it to whatever you want. Put in some numbers if it helps you keep track of indices. Try slicing in various ways. Try positives, try negatives, try steps. See what you can get. I'll give you a minute or so for that. Okay. So I think I showed you most of the combinations already, but arbitrarily with the string here, I sliced it using blank colon 1. So that means I'm getting everything from the beginning to everything at the end in steps of 1, which is just printing out the string itself. So you get the string itself back. Don't know why you'd want to do that, but it's how it works. Go to -2, cuts off some of the end. But here's something fun. How about, what if we go from -1 to 0 in steps of -1? What's that going to do? You get the string backwards, though with the quote-unquote first letter cut off, because again, the final index isn't included. I could go backwards in steps of 2 if I wanted. Good to know. Okay. Now this is all well and good for strings, but perhaps more importantly, you can do all the same stuff for lists as well. So in this next cell, we have the sequence, just 1 to 6. Try slicing it. Pull out some list of numbers, pull out like, steps of numbers that aren't just one away from each other. Actually, I think that's what the next cell is, so I'll just do this myself really quick. printing out the values from 1 ending before 6. I indeed get these numbers, put in a step value, go by 2. Okay. And for the last minute or so before break, y'all try out this exercise. Try slicing up some lists. Create a list, put some items in it, and try stepping over it for practice. And similar to the challenge we had before with length, try printing the sublist, which is just the first half of the list. That is without knowing the exact index of the halfway point. See if you can do that. Okay. Was anybody able to get just the first half of the list automatically? Anybody who would like to share? So we'd be filling out these slice and step values in some way. If we want the first half of the list, I think we can probably leave a starting point blank. We just need to find the appropriate endpoint. Probably don't need steps as well. How about we go to the halfway points of the list. Does it work? What went wrong? Why didn't mine work? Anyone have ideas? Yeah, y'all got it. Integer division. So I've tried to index using a float here, and that doesn't make sense. What is the 1.2th element of a list? That's nothing. It's got to be an integer. So 2 slashes. There we go. I got the first half of my list. The middle point would have been this 6, but again, remember, it doesn't include the very last index. If I wanted the back half, I would just make that the starting point. There you go. Okay. It's 2:32, which has been about an hour again. Let's go ahead and take a break. Okay, everybody. It's 2:42. It's about 10 minutes. Let's go ahead and get started again. Okay, so we are in the second notebook, and we're down to this methods section. One thing that might have been neat to point out earlier, but I forgot about, you can actually get a table of contents in these notebooks. If you go up to View, Table of Contents here, and it'll give you quick links to like all of the headers that you can jump to. So if you lose methods, you can click on what are methods down here. That's where we are. I'm going to go ahead and close this though for less clutter. Okay, so what are methods? Methods are a subset of functions. Remember functions, function name, parentheses with stuff in them. Methods are similar, but they're a smaller subset of them. To describe how methods are related to functions more broadly, by way of analogy, think of opening a can of food like these. You need a function to open the aluminum can. There's 2 ways you might do this. You could bring in some external tool, a can opener, which is more or less universal and works on most cans. However, some cans come with a pull tab attached to them. That one pull tab opens that one can very well, but only that one can, specifically that can. Which option is better, quote unquote better? It depends what you're doing. A method is like the pull tab. A method is a function that is attached to a particular piece of data, and it works just on that piece of data. I mean, there exists some that'll work on other things along with that piece of data, but that's getting into the weeds. The gist is the method is attached to some given piece of data in a way that other functions are not. The way you write, or the way you call a method, is just something like this. You have whatever your data is, and then you put a dot after it, and then call the name of the method, or the name of the function. Generally, when you do this, the method knows what it's attached to. So whereas previously you'd be passing your data as an argument to a function, here you're oftentimes not going to be doing that. The function already knows what it's attached to. You wouldn't be passing, in this case, data as an argument back here as well. So as an example, let's do a string method. Strings have a bunch of methods. In particular, let's try out the title method. First of all, let's see what we can learn about it. This is something I forgot to mention earlier. So I showed you all the help function back in the previous notebook, right? You can pass a function, or in this case, a method to it, and it'll give you some information about it. You can also put the single question mark after the method, and it'll give you something similar. So in this case, we're looking at the title method operating on a string. In this case, though, it knows that we're talking about the string title method. We prepend it with like string, the data type. And it tells us that it's going to return a version of the string where each word is title case. Okay? So let's try that out. In this cell down here, type in your full name as a string, that is in quotes, but do it with only lowercase alphabetical characters. Then you're going to attach the title method to the end and see what that gives you at the end of it. See if it title cased it. I'll give you a minute to try it out. So here, for example, I typed in my name just by itself. I executed it. Since I'm only printing one thing, I didn't do the print statement against my own advice, but just for speed. Say I want to title case this now. At the end of my string, I do dot title, open close parentheses. You still need the parentheses even if there's no argument. This is just like function syntax. They all have the parentheses if you try to call them. So now I run this again, and it's changed the string. Lowercase j became capital J, lowercase w became capital W, title case, right? Okay. Now, there are a bunch of other methods, like for strings and for other things. How much you go about finding them. This example here is with lists. Let's, I'm going to change it to be with strings just while we're at it. In this interface, at least, we can use tab to autocomplete and give a suggestion. So let's just type in some string here, type a dot, and hit tab. And I get this little pop-up here. It shows me a whole bunch of possible string methods. Looks like it's trying to give me a little window with extra information, but it's flickering. Oh well. You see there's a whole bunch of methods here. We're not going to go through all of them. Capitalize seems straightforward enough, though. I'll just hit enter to put that in there. Open close parens. Oh, capitalize just the first one. I was expecting a different one. I think the one I'm thinking of is upper. Yeah, that's it. The upper method makes like everything uppercase. But so again, what I did there was I typed a string, the thing I want to operate on, dot, and then just tab. And in this interface, at least, I get this pop-up. Outside Jupyter, it may not work quite like this, but this is a good, convenient way to find it if you're in Jupyter. If you want to know more about what it does, as I showed before, you can, oops, forgot what I was doing. You can, oh, question mark didn't work. What did I do? Maybe one string in particular. Yeah, that's it. Or as always, search engines. Search engines are handy. I'm trying to stick with the built-in Python stuff, but sometimes there's better ways. I'll leave that up to you, though. Let's do something similar with lists, though. Lists, well, you can do a lot of different things in lists with lists than you would with strings. So let's just type list dot and tab to see what we got. Okay, not quite as big of a list, but not a small list. This copy command is something we're going to come back to in a little bit. This could be very useful. The rest of these, though, we have some space here to try out. Let's start with the append method. Say you need to add stuff to a list. You start maybe you started with a blank list like we did before. Before we started with a blank dictionary, right? And we specified keys and values to put in. How would you do the same thing with lists? There's no keys. The append method is one way to do that. Start with a list, any list, could be an empty list, and call the append method on it, and the only argument will be what you want to add to the list. So here I have a list with 3 things in it, and I'm going to add a 4th. Printing before I call the method, I have just the original 3. Printing after the method, I have all 4. And as I suggested, you could do this with an empty list too. So say I start with just empty brackets as my list, call append on it, it still adds the thing. That's fine. Other things we can do with lists, we can reverse or sort them. I'm going to show you an example with reverse, and then I'll want you to try out sort. The reverse function will alter the list in place. Let's see what that means. So here, we're calling this range 10. Remember, range is just going to be a list of numbers. In this case, because it was 0 indexed, it'll be 0 to 9. Calling the list function on it to make it a list instead of range has its own object. I don't want to go into that right now. So if we just print it, you're starting with this list of 0 through 9. Next, we're going to call numbers.reverse, the method, and it's changed. Now note, we didn't set this equal to anything. We didn't do a variable assignment. Like we didn't get like numbers reversed equals numbers.reverse. The reverse method changes the list in place, like right where it is. And sort will be something similar. So time for y'all to practice. Down here under, under exercise sorting lists, create your own list, have several strings in it, and try sorting it using this sort method up here. I believe it'll also change it in place, similar to reverse. So you shouldn't need to reassign it or something. Just call the sort and print it out. I'll give you all a minute or two to work on that. Have at it. Okay. Did y'all get it? Any questions? There is at least one subtle way that this could go wrong, which I can demonstrate here. So the way this should go, we create a list. See in chat, someone leaving. The recording will be made available later. Yes, it'll go on our YouTube channel. There will be some processing time though. It might be a week or two, I think. But yes, it will get posted eventually. Thank you for joining. Okay. So list here, sorting list. So here I've made my list with these 4 things in it. I was thinking trigonometry for whatever reason, angle, hypotenuse, acute, delta. If we print the list, first of all, let me just comment out these. Just print the list by itself, we get the list back, fine. If I do myList.sort just by itself, I don't get anything new here because the sort method doesn't send stuff to the output. We have to print it once again to see that it happened. And you see now it's in alphabetical order. Now, the kind of subtle thing that might trip you up is it's very similar to what I talked about earlier with the print statement not returning anything. Your instinct may be to like print myList.sort. If you do that, you get none back. Again, similar to what we did with print back in the previous notebook. The sort method, it doesn't return anything. It just changes the underlying list. So that's why the quote unquote proper way to do it is to call the sort and then print the list. Because you're not printing the return of the sort. There is no return of the sort. The sort just changes the data, and then you'd want to print it afterwards. Again, very similar to what we saw with the print statement not returning earlier. I wish I had a more intuitive way to talk about it. At the very least, I can bring it to your attention. So in case you run into this and you start printing out nuns, this could be one reason why you assigned something that didn't have a return. So just be aware of it. Okay. Did anybody else run into other problems in this exercise? If not, then we can go on to dictionary methods. Dictionaries will again have some separate set of methods, different from what strings and lists did. Maybe some similar ones, but also some special new things because dictionaries are organized differently. So, given this example dictionary with 4 items in it, just based on the names, can you guess what these methods in the following 3 cells will do? If you print out the example dict.keys method, well, I sure hope that's the keys. It's the keys. 1, 2, 3, 4. Print out the values. That is the other half of the key value pair, right? So example dict.values is probably the values. Money, gold, ready, go. Yes, sure. Print out items, lastly, it's just everything all together. Yeah, and now this is not quite a dictionary back out of it. These are like pairs of values. It's not just the same dictionary. Let's try this. Here's a challenge for you. How quickly can you make a dictionary that is the same as this one above, but with the keys and values switched? That is like without typing out a new set of keys and values. Can you use these methods to like reverse it? I'll give you a couple minutes to try that out. And do let me know if you have questions along the way. You'll probably want a for loop or something. Okay. Where are y'all at? Would you like more time to try this? Or does anybody have the solution already? Well, hearing no feedback, I'll give you all like 1 more minute, and then I'll. Now you're running into errors? Okay. Do you want to fiddle with them yourself, or else you can post them in chat here, and I'll see if I can give you pointers. Pointers in the generic sense, not in the C++ sense. You know what, actually? So we've got about 1 hour left in the class. Let's go ahead and take one final break. And y'all can think about it or work on this over that break if you want, or not. Let's come back in another 10 minutes, and then we will finish out the notebook after that. Okay. It's 3:16. Let's go ahead and get started again for the final round for today. Okay. So the challenge here. Did anybody come up with a solution? If not, I will wing it. Daniel has a clunky solution. If it works, it works. Do you want to share it? It's fine if you don't, but I'd be interested to see. Oh, different computer. All right. I'll let you off this time. Okay. So here was my first thought. So I want to take this example dict and reverse the keys and such, loop through the values and keys and update the dict with each iteration. Yeah, that's basically what I'm going to do. So I want to turn example dict into a reversed new dictionary. Let's go ahead and shorten this to save typing and for the parallelism. So we have example dict and new dict. I'm going to start new dict as empty. And then I'm going to iterate, I think, over the keys in the original one. So for key in example dict dot keys. I'm first just going to make sure I got it right. How about I print the key? Are these all the keys? Yeah, 1, 2, 3, 4. Those are the keys. Yes, very good. So what I want to do is create new entries in new dict using these keys. And since we can index with the keys to get the values, I don't think we need to mess with these other methods here. So how about new dict? New dict at some point is going to equal something. This first one, I want to get money. How do I get that? Well, it would be example dict with the relevant key, which is what I'm looping over. So I can just use key here. And that's going to equal the key itself. Right? So like I want to switch these two. And in the first loop, I've got that first key. I have the 1. So the new key, which I'll put on the left side of my equal sign, is going to be the value of the original, which I get with the key. And then I'll just put the key on the right. Okay, is that it? I print new dict at the end. How do we do? Money 1 equals 2. Ready 3, go 4. It works. That's it. Not really that long, but you got to keep track of like several things that you're referring to. Loop variables and indices and such. You could alternatively have like done a for loop over range 4 maybe, and then indexed the keys and values out of the example.dict keys and example.dict values objects, or index them out of the whole items object there. I'm satisfied with this one though. It's relatively short. Are there any questions on what I did here? If not, then let's move into this final section down here. It's labeled optional content. I think we have time to go through this. First of all, I want to introduce another data structure. So far we've been doing lists and dictionaries, right? And we've seen tuples previously, briefly. There's another one of those here, and it's called a set. Sets cannot have duplicate elements, which can be useful. You create a set using curly braces like dictionaries, but you only provide excuse me, but you only provide single values, not key value pairs. Or if you have an iterable already, you can like typecast stuff into it using the set function, similar to what we did with the list earlier. So for example, set 1 here with the 4 classical elements with some repeats. If I print that set, we're going to see that it turned into just a unique list. I'm going to comment out that second half first. So set 1, I put a bunch of stuff in it. It automatically condensed it down into just the unique ones. That's handy. Let's create another set. This one is starting with a list. See how it's got, well, it's the same entries as before, but it's inside square brackets. That's a list. And then we pass all that to the set function. That should give us the same sort of thing. Let's turn this off up here. We turned it back into a list because why not? Print the unique list, and you end up with, well, essentially the same set of objects as before, except this one I made a list for arbitrary reasons. Truth be told, I have not used sets very much on my own, but sometimes that uniqueness can be useful, so be aware that they exist. Let's talk about in with data structures. We previously used in for substrings, right? And I think a little bit with some of the loops. You can also use in to check if a given object is in one of these data structures. So here we have my list with 4 strings in it, blue, red, yellow, green. You can check if any of these strings are in this list. So is red in the list? Let's just do that. Yes, it is. Returns true. Is mauve in the list? Returns false. It's not. Just to double check, if I add it in here, is it true? Yes, it's true. So again, similar to finding substrings, but now it's finding like this whole data object, in this case, the string red or the string mauve. With dictionaries, it's a little weird, if I recall correctly. Yeah. It's looking for, here the n finds keys. So is red in this dictionary? Yes, it's the value over here, but it returns false. Is color 2 in the dictionary? Yes, it is. It's a key, and that returns true. And then mauve, again, is not in it at all. So, of course, that's false. I don't recall myself using in for dictionaries very much, but again, it's possible. More often, you may be interested in doing like in my dictionary .values or something. In fact, let's go ahead and try that. Remember the values method that we saw a little ways up. Because see, that's true. Red is in fact in the values. Any questions on those two things, sets or in with data structures? If not, then let's see, list concatenation, I believe we did earlier, back up at the top. Yeah, we did. Just as review, remember, you can use the plus sign to stick lists onto each other. Oh, duh, gotta print it though. Yeah, like that. This exercise was an indexing exercise. We can do that together really quick. Let's try to reduce this to just the items that that are like real words. I want to print. No, that's not what we're going to print yet. Cut down on the symbols. Let's do, if we want to get just the normal things, we want to get bolts, nuts, wrench, safety helmet. If we want to get just these first two, we can slice that. First two would look like this. And then using list concatenation, we can jump ahead and grab something else. We want wrench here, which is in space 0, 1, 2, 3, right? So let's do that. And then we want to skip this chunk and get just the last element. The last element, my favorite one, is at -1. Hooray for negative indices. Let's just call that. I won't even print it. Oops, what'd I do? Can only concatenate list, not string to list. Okay. So, so the slice here, this returned a list. Let's actually just do that. That's a list, right? Two things in it. If, however, I pulled out just a singular element, that's not a list. It's not even a one element list. It's just the object itself. So we need to somehow pull out these individual elements, but make them lists. How might we do that? Well, we can use that list function again. We've seen that before. Oops, I didn't quite do it either. It spelled it all out, which is not what I wanted. What if I just put it like inside of a list, like this? Hey, that did it. Does everybody understand what I did there? The syntax is kind of annoying to see. Maybe actually the print statement would help here, because if I put it inside the parents, I can put them on new lines. Yeah. So you'll see the difference in syntax between the first entry and the second two. First one I didn't have to mess with because the slice is a list. The second two, though, were just individual elements, and I had to make it a list somehow. And I did that just by putting them in square braces. That's how you define a list, right? Any questions on that? If not, then I'm going to leave the next exercise to you. Remember I showed nested dictionaries earlier, and the way I pulled out elements of subdictionaries was just two brackets, right, next to each other. Y'all are going to do something similar. Make a list of a list of lists, or a list that has at least one other list in it. Print it out, make sure you got it right, and then pull out individual elements of one of the sublists. You have space for that down here. So yeah, make a nested list and pull out elements of the inner lists. I'll give you all a minute or so for that. Let me know if you have questions. Okay. Someone tell me, if I want to pull the letter B out of this nested list that I have here, how would I get it? What would I print? Daniel says L1 4 1. Let's give it a shot. L1 4 1. B, it works. Hooray. So what we did here, we got element number 4, right? So here's L1, 0, 1, 2, 3, and then the last element's another list. So element 4, yeah. And then you index that thing that we got from the first index with the index of the thing we want. So 0, 1, that's the B. So L1 4 1 gives me B. Everybody good with that? Make sense? Thank you again, Daniel. Okay. If there's no further comments, then let's talk about the list copy method. This I advertised earlier. Remember how, like back up at the top of this notebook, we made a list and then another list that was equal to that list, and then you change the list and it changes both at once, right? Sometimes you may not want that. That may be confusing. The list copy method is one way to break that behavior. So remember what we did before. X is 1, 2, 3, or whatever. Y is equal to X. Pardon. Y is equal to X. Print X and Y. That's the same, of course, because we set them the same. But set first element of X equal to something else. Print X and Y again. And now they both changed. Maybe you don't want this. The copy method is what will break this for you. What you can do is instead of Y equals X, you do Y equals X dot copy. No arguments. So now this is specifically made like another space in memory somewhere else that X is not pointing and Y is not pointing to that separate copy. So when you change X to something else, like down here, the Y is unchanged. This may be useful to you. Make sense what I did there? Remember that copy method. I forget if we're going to practice it in the next class, but in that next class, when we do more like data science things, a lot of the objects that we use in there will also have a copy method. You might ask, like, why is the default behavior to make them point to the same thing such that you changed both? I'm not, of course, the person who made that decision, but my suspicion is that it's a matter of like saving memory. Because when you start doing like big data science and you have these tables with millions of numbers in them or whatever, if you want a variation of the table, you don't necessarily want to copy that table. You want to have like the same block of memory in place, and you don't want to duplicate it. You just want to have like a modifier on some piece of it. That being in mind is my suspicion for why they have this weird, this pointer behavior. And then you have the option to break it up if need be. That's kind of just me That's kind of just me hypothesizing, though. Point is, you may see this again next time. Okay. Key error, perhaps you've seen before in dictionaries. As you might expect, if you ask for a key that doesn't exist, it'll give you an error. And it's fairly simple to understand. Key error, and then the key. Let's see. Nested dictionaries, I showed earlier, kind of jumped the gun. Zip function. Zip function is useful. Let's try to talk about that. We have time. Zip function is a way to like pair up multiple values. And for example, you can create dictionaries with it. What's the best way to show this? Down here in the cell you have filled out for you. Oh, yeah. Down here in the cell you have filled out for you these two strings with the same number of characters in both. And you're assigning to this pair. Excuse me. Gosh, falling apart. Day's almost over. We're assigning to this pairs variable zip string 1, string 2. Let's just print that out to see what it does first. Oh, that's not useful. He gives you a zip object. Thank you, zip. Okay. Well, putting it in a dictionary will make sense. Let's just print out sample dict. Okay. And the syntax is a little hard to read, but you see, the first key is A, which is what the first letter of the string was, and the first value is 0. First string, or first character of the second string, and then second, third, etc. Maybe there's a better way to talk about zip. I think I even skipped in the previous notebook. My bad. Let me show you something else. What was it? I'm going to copy these strings. The previous notebook had an example with a for loop, and perhaps I should have gone over it in more detail. You can have multiple variables in a for loop. So remember, we used to have, for variable name in iterable. Here I'm going to do for two variable names in zip as my iterable. 1, string 2. And perhaps I should not be winging it, but we'll see if it works. Yeah, there we go. I hope. So the zip statement is like packaging them up to be split up again in some form, either through multiple variables in the for statement or in a dictionary like this. Most often I use zip in what are called list and dictionary comprehensions, which I think are at the very bottom of this note. Oh yeah, they're right here. Okay. Maybe I'll come back to this in just a moment. I'll come back to it now. Let's just talk about comprehensions. So this is kind of an advanced thing. If you're tired like me, if you're coughing like me, and you're not paying a whole lot of attention, that's okay. This is all kind of advanced stuff. I do want to show you list and dictionary comprehensions, though, because they're extremely Pythonic. Python people use these a lot. In Python, you can create structures like lists and dictionaries with a very compact for loop. Ignore this bottom part for now. You'll see what's happening here. Start with an empty list, and for x up to range, for x in range 0 to 6 or 0 to 5, you just append. Let's just simplify that. Oh no, we'll leave it. Append x plus 1 to the list. If we just run this, we get 1, 2, 3, 4, 5, 6. This is normal for loop stuff like we've seen before, right? And then we saw the append method for lists as well. We can condense this down a little bit as a list comprehension, as we call it. The same for loop thing you can do like this on a single line. List 2 is, since it's a list, we put it in square brackets, x plus 1 for x in range 6. So it's like we pulled out the meat of the loop into this front part and then tacked the for condition on the back. And we end up with the same thing, exactly the same thing. If we like do our quality test. Comes back true. They're exactly the same. I did this a lot in Python. Okay. Again, though, if you don't quite follow what's happening here, that's fine. You don't have to do this. This is just, maybe it's just for people like me who want to squish down to minimum lines possible. Once you get used to reading it, maybe it helps with readability as well. But here, for example, at the very bottom, this is where zip comes back. I do recall using zip in list comprehension or in dictionary comprehensions like this. This is a lot of symbols to read, but what's happening here is we're setting up a dictionary with key value pairs for keys and values as packaged up by zip. And the keys will be A, B, C, D, E, and the range will be 1 to 6. Well, 0 to 5, sorry. Yeah, 0 to 5. I was thinking of that one up there. There we go. Nay says this method seems a lot more intuitive. I'm glad you think that. If you like it, have at it. I like it a lot. I do find it difficult to explain like the leap between the normal loop and the comprehensions though. Because you can do really crazy stuff in like a really condensed manner like this. So if you like this, that's cool. Have at it. Okay, that is, however, the end of the notebook. I threw kind of a lot of somewhat advanced things at you at the very end here. Are there any final questions at this time? We will stick around for a while, but I think we're going to go ahead and close out the class, or end the class. We'll leave the Zoom open for a little bit for questions. But yeah, this is about all. Yeah, this is all I wanted to talk about today. So first of all, thank you for joining. Oh, I remembered. If you don't mind, take our short course survey sometime. Let us know how we did. Let us know what kinds of things you'd like to see in these classes. Otherwise, if you're interested, remember, we've got 2 more Python classes coming up, I believe in November, Python for data science and Python for HPC. So if you're interested, come back for those. If you've been through this class, you should be set up for the data science class next. Otherwise, this is about it. Y'all will have, thank you for joining, everybody. A couple final words about the notebooks here. Y'all will have access to ACES, this cluster, probably until like the end of today or so, so not much longer. If you want, though, you can just download these notebooks and run them somewhere else if need be. Like you could do Google Colab or VS Code. VS Code has a Jupyter extension. You can find these either download them from here while you're here, or again, they're posted on the course webpage down here. I think that's all I had to say. So thank you again, everybody, for joining. We'll stick around a little bit longer for questions. If you want to keep fiddling with these for a couple minutes, feel free. Otherwise, have a good day, everybody. Thank you again for joining. Ian, you're trying to download the notebook. You're saying like it opens in a new tab. Is that with the file menu download here? Maybe you like opened it, maybe you saved it as HTML instead of downloading the IPy notebook. Oh wait, do you mean the notebook on this web page? For me, it's still just downloaded as a notebook. Did you open the Jupyter Notebook or one of these Google Colab links down here? Because Google Colab will open in a different window, I think, or a different tab. If these other links are opening as HTML. I'm not sure what to say there. That should not be happening. So like you click on the link and it opens automatically as HTML? Curious. Does it, I assume it doesn't look the same. Does it have a lot of like, does it look like a bunch of dictionaries? Like a bunch of keys and colons and curly braces? I'm wondering if you're looking at like the JSON info. Oh, you got it? Okay, cool. Thank you. Do y'all have any questions? We're going to close the Zoom in a couple of minutes, I think. Okay, I think we're going to go ahead and close up. Xiaoming, if you have any other questions, feel free to contact us later, and we'll get back to you as soon as we can. Thank you for joining. Have a good day.